got science on our side. Flat Earth beats all, it's all pretend. The facts will be done. Get ready for the smackdown. Get ready for the smackdown. They'll lie while the Earth spins around. Watch out for smackdown. They cling to ancient misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put Flat Earth in its place. Here comes the smackdown.
Welcome everybody to Tuesday night. I'm your host MCToon. I hope you're ready. We're going to be going into a Discord server full of people that think the Earth is a big old pizza. The whole thing, it's all just a big pizza. Anyway, couple things quick. Tomorrow, top left nominations. We're going to start it out on FDFE's channel, then come to my channel, then come to the Crunk Debunks channel. It's just, they're just going to all be linked. All you need to do is show up at the first one and then come along for the ride. Number 2. Starting a new channel. We're showing things being built in my house. I'm going to use my Toon Show channel. It's got like 3,000 some subscribers. I haven't done anything on it for a little while. It's become it's lost monetization. If somebody wants to post a link, I'll pin the first person that posts a link, pin it to that channel. I'm going to be releasing stuff there. I don't know if you're going to care about it or not. It's me working on stuff around the house. My kid said, hey, you taught us how to build stuff. You should do it on YouTube too. So I'm gonna. Anyway, that's what I got going. Now we're gonna pop over to the Discord server. The link to the Discord server is in the description. And oh, my camera. I need to move my camera up just a second. Uppity, uppity, uppity. There it is. Move that up, and then that I need to move down. There you go. That should be good. Camera 3, was it there? That shouldn't be there. All right. Here it is. There's the server. So we're going to be on the stage in there. I'm going to pop in and say hi. Hello, everybody. I am live on YouTube and on Discord. How you doing? Icy Spin, Arnold, Jesse.
Hello, hello.
All right. I can see that they can hear you. That's how it works. There, Icy Spin got my new channel there. My old channel, my new old channel, old new channel. Anyway, welcome everybody. As some flat earthers have an opportunity to come on in to the ring here, and we'll see. Yeah, how they're doing. But in the meantime, while a couple of them I know they're gonna come in a little bit. So this is done as a stage. So people, if you're interested, you can you're invited to come up. Specifically, it's going to be for flat earthers. I have a little presentation I'm going to do, and then the flat earthers can respond on topic is what I'm going to ask for. And, you know, if you don't...
We've got...
Yeah?
Oh, sorry. We've got the Press Dawn requesting to speak if you want to bring someone up early.
Just a little teaser? All right. You just don't even know the topic yet. But the Pressed Dawn, I don't know who the Pressed Dawn is, but okay. Let's say hi quick before I get to the presentation.
All right. Here we go. He has been invited.
All right. The Press Dawn, welcome. Any thoughts? The Pressed Dawn. Dawn. Sorry. Huh. Well, you should be able to see. Yeah, there you go. On my on my screen, you should be able to see there. Yeah, there you go. That the press Don was added as a speaker. So, and I'm not having success sharing my screen to Discord. So what I'll do is I have just a couple things that I'm going to present, and I'll just put screenshots into the Ring side chat. So anyway, did anybody hear Don?
No, I think he's having some audio issues.
Okay. All right. Well, the topic du jour, which means topic of the day, sounds good. I'll have that. Is something I've heard different flat earthers say at different times. They have said that Earth is measured flat, and I've yet to see these measurements in action. I have seen people say it's measured flat, and then when they're like, oh yeah, we're going to go through it, and then what they do is they start with saying that the Earth is measured flat, which is in the wrong order, right? You need to start with what you're doing, and then at the end show the measurements. It's very much backwards. So what I'm going to do is I'm going to actually test those claims with measurements I took myself, my own personal measurements that I took. So, all right, Don is still struggling. Right. Well, anyway, I live at 45 degrees north latitude here, and the angle, the elevation angle to Polaris is 45 degrees. And so that's the one I'm going to start with, but I've also measured it in a couple other spots. But I want to just, we need to establish first what the flat Earth position is. Now, flat earthers, if I'm wrong, you bring, I don't want to be wrong. You bring me, please, the correct understanding, the correct model if I'm getting the model wrong. But all I'm doing is I'm taking the model that flat earthers have used and presented for the last 175 years. And there's a couple exceptions, but for the most part, there are, this is the model. It is the one that's described here by somebody that's been on this channel, on this server, in fact, a couple times. I'll just play his audio through to, let me make sure to zoom. I want to just make sure that you're going to be able to hear it over there in Discord. To zoom. There it is. Yep. All right. So let me first. All right. Here we go.
Take a measurement at Polaris, so it's directly at your zenith, and then you move back. What would it be? 69 miles, right? Or 60 nautical miles. Yeah. And then you draw a circle around Polaris, right? That represents your first flat plane. Now, given that they know the extremity, they already know what the equator will give them, i.e. they know how to lay out the radial value at the absolute extreme. All you're then going to do is map out all of those points per degree as flat plane slices that go down towards the equatorial plane, getting larger as you go away from Polaris.
There it is. So there is a flat earther that's been around for more than 10 years describing how it is. You've got Polaris in the middle, and then as you move farther away, every as the elevation angle to Polaris descends by 1 angular degree, you move 69 about miles farther out. So by the time you get to the equator, you're in a circle around Polaris, and then of course it keeps going. Unknown how you would get your latitude using that method south of the equator, but we're not really needing to address that tonight, because because I don't have any measurements to Polaris from south of the equator. So I don't know how that was obtained, but this is amazing. Amazing stuff. So that's what I've done. And so in Minneapolis, I did in the Minneapolis area, didn't measure this in Minneapolis. I measured the angle to Polaris as 45 degrees. I'm just going to use 3 sig fig here, and I'll show you on GeoGebra here. Here's my GeoGebra calculator, and there is the formula that shows that plots out the angle that I personally measured to Polaris, applying the geometry that was just described there. So here I am. I'm doing this in kilometers because this is science. So we've got 5,000 kilometers from the North Pole on the claimed flat Earth, and the angle is 45 degrees, putting Polaris at 5,000 kilometers in an angular elevation directly above the North Pole. This is the claim from flat earthers by their geometry. I'm simply applying the geometry. Now, I've measured, well, let me just explain the formula here. So the formula is y equals negative tan 45, right? Negative tangent of 45. So I'm plugging in the angular elevation that I measured there, and then x minus 90 minus 45. So that is to get my times 111. So it's kind of off the screen here. Let me fix that. Times 111, which is again kilometers. So that's to get the distance from the North Pole using the same formula that was just described by that flat earther and by many flat earthers. So that's how you do it. So now I have been in Pensacola, Florida. I measured it myself, the angle of Polaris, using the same method as described there in Pensacola, Florida. And you'll see here that's this farther away from the North Pole. It's over on the right side here, right? That's where I was, nearly 7,000 kilometers from the North Pole. And now we get an angular elevation of Polaris as less than 4,000 kilometers. I don't know how that works, because it was asserted through basically a begging the question that Polaris is, or that the measurement somehow is flat. But I'm testing it, and so far it's not working here, because now we're getting 2 different elevations for Polaris. Now I'll add in the third one of note. I was recently in Puerto Rico at 18.5 degrees north latitude. I'm gonna plug in the same formula there, which is nearly 8,000 kilometers from the North Pole, and that gives an angular elevation, or a linear elevation of Polaris, by just applying this geometry, of like 2,800 kilometers. So this is the same star applying the same geometry as described by this flat earther who has made these claims, and nothing works here. We're seeing each location gets a different elevation for the star. So the geometry claimed by this flat earther doesn't work when he says Earth is measured flat. So I'm so far struggling to find how Earth has been measured flat. None of this works as described. I'll post into the chat the GeoGebra formulas that I'm using. I'll drop a screenshot as well in the chat so the people over in Discord can pick it up and have a look at it themselves. So there you go. There is the what I'm seeing according to this flat earther and many flat earthers. When you look at the Gleason map, this is all the same information on the Gleason map. So you get Samuel Rowbottom, Alexander Gleason, Eric DeBay, Flat Earth Dave, Nathan Oakley, Nathan Thompson, everybody that's ever put the Gleason map on their wall behind them while they live stream. All of those people, this is their claim. Now, if I'm getting it wrong, then I do want to to be corrected. So yeah, I see CK. I tried to start my stream, but I wasn't able to, and so I see Jesse is sharing my stream there. So anyway, there is my presentation. So the topic is how can we rectify this discontinuity between the claim of Earth measured flat and when I actually apply the measurements and go to and do the work, do the geometry that has been described by these very same flat earthers, I do not find any agreement in the claim. So yeah, does Don, did you have any success getting in? Maybe he.
Let me ping him in chat, see if he's
see.
He isn't here yet.
Anyway, so Jesse, all right, Jesse, how you doing? What do you think about that? Have you tried to apply the Earth measured flat claim?
Yes, I've had no success measuring it flat.
When I actually do what they say is the geometry, it crumbles pretty quickly. So that's kind of a bad thing for them. And so the verbiage that they use, I know you've probably heard this, Jesse, is they'll say Earth is measured flat, and you can't take an angle measurement without it being flat, which is really weird because the angle measurement isn't actually in any way related to the surface. When you set up a theodolite, for example, you don't use the surface of the Earth as your reference for the theodolite when you're setting it up. All that you have with a theodolite as your reference is the vertical vector that is bringing the bubble in the bubble level to the highest part of that vial.
Right, and by their same reasoning that you couldn't measure an angle to something unless Earth was flat, you couldn't even if it was, because you would be standing on a hill or in a valley, and you would be measuring an angle to a mountain peak or something that also wasn't flat.
True that, yeah. All right, Don, any luck getting your audio going?
Can you hear me, by the way?
I can hear it.
You spin.
I got some spin going.
Don, still no Don yet.
Yeah, I was having some major issues with Discord, so I had to.
I think the internet needs to be rebooted.
Yeah, somebody pop over to Big Ben and climb up to the top and reboot it quick.
Hey, MCToon, am I audible now?
Hey, I can hear somebody. Was that you, Don?
Yes, sir. Hello.
Hey, I'm
How
here.
you doing, Don?
Yep, sounds good, Don. Oh, maybe it's stopped working. Maybe it was.
Oh, no, I didn't know if it was like I've never been on the stage thing. I don't know what you have going on.
Oh,
I don't want to interrupt.
Yeah. Well, no. This is a invitation to any flat earthers to help rectify the claim of Earth measured flat with an actual application that I just went through of trying to apply the claim. And it just didn't work. And so I'm just, wondering if any flat earthers around actually do think that the Earth is measured flat, and if they do, can they somehow fix this discontinuity between the claim of Earth measured flat and when you actually apply the measurements that they don't match. So I got somebody here. This is interesting. I got somebody on the YouTube live chat. Shayam blah blah shimna says MCToon is misleading with wrong geometry. Well, this is your lucky day, Shamalama Ding Dong. You can jump on to the Worldwide Debate Discord server Link is in the description, and some people have posted it here. And then just pop in and present the right geometry, how we get that. I'd love to hear how it's done. And and maybe I don't quite have the geometry background that you do. Don't worry about it. Present it. Don't try to tame it down. Dig as deep as you need into the geometry. But anyway, Don, I don't know, Don, did you hear the presentation? I know you're having trouble with audio.
I didn't.
Okay. Well, I'm not going to.
I've seen Jesse. If it's from Jesse, sir, I'm sorry. I've seen his stuff before.
It was not. It was from me. I took my own personal measurements of the elevation angles to Polaris, as many flat earthers have said is how you do it, and then applied those angles and did triangles, which those very same flat earthers say is how you do it, and it did not work. I got three different elevations for Polaris that vary based on where I am on the Earth, which doesn't make sense, because if you are, if I'm being told that you make triangles using elevation angles just to Polaris, right? That's a triangle. You've got a right angle triangle, you've got the line from the star to the Earth, and then a right angle to where the person is at, and then the elevation angle back up to the star. That's what's been described by specifically by Nathan Oakley at length over and over and over. And so I just tested that very claim, and it doesn't work.
Okay.
So
I heard QE say today that he's seen Polaris from 13 degrees south latitude.
wow.
Or he's heard, not he's seen it. I'm sorry. He's seen a report that said
He's seen a report. Interesting. Well, that would then, just to like post a link to it or something would be really cool. I suppose he didn't have a link to it. Was it just trust me, bro?
He said he could find it. I just was listening. He said I can find it. It's from 2016 is what I heard him say.
Yeah. I'm going to guess that he will never actually present this thing. So it was said by it was said by Flat Earth Dave multiple times. He said that there's an observatory in the southern hemisphere that has reported it, but he's never actually produced it. He's just said it. So I'm not really into the trust me, bro. Let's see. Let me see. I know. So one of the original claims is from Samuel Rowbottom, who said that in the Captain Wilkins reported the Southern Cross and Polar Star were both distinctly visible by midnight, which is true, but they were at 35 north, not 35 south. No, 23 latitude north, not 23 latitude south. So Samuel Rowbottom started way back with an incorrect claim about that. So, but now 23 degrees is not 13 degrees. So what was the QE talking about? No idea. So, any other Flattys? I mean, it's a tough one. It's a tough one to actually do the thing that, to actually, do the work to make a claim and then back up the claim.
Yep.
Yeah, it's a tough one.
It's tough, and that's why some of the globe evidence to me is still argued about the way it is.
Yeah, so that's a different topic though. So,
yes, sir. I understand.
Yeah.
Yes, sir.
And what I've found typically is when So this is the opposite, right? I'm here begging to be provided the correct geometry, versus the other way around, where I've seen flat earthers go and do the wrong geometry for the globe and then refuse to acknowledge and accept the correct geometry for the globe. Right. So I'm doing the opposite of what is the typical flat Earth position. I'm asking for the geometry, and so I've invited the guy in my YouTube live chat. I don't see him yet in Discord here. I don't know if he's going to come in with the same name or not. We've got Dick Wayne sometimes shows up, and he likes to talk a lot, but he can't actually do geometry either. So
Well, I'm not the best at it, sir. Have you been? I'm sure you've been exposed to like that Shane St. Pierre model thing where they tried to reconcile the sky angles.
yeah, Shane can't do geometry either, though, and Alan is even worse. Alan, he thinks that a hypotenuse is measured in degrees, so that's pretty funny. But I've seen them try, and it's usually just a whole lot of spinning around in circles and not actually doing anything with flat Earth geometry. Instead, they always go just like you kind of did there, is to go back to the globe and kind of the misapplication of it.
Well, I don't understand it good enough.
Are you talking about the celestial theodolite, Don?
No.
Are you talking about the azimuthal grid of vision, or
Maybe the one where they had the flat Earth, and then he had like the stars, like in the sphere,
Yeah.
like half above
where
it
everyone
and
has their own person?
Yeah, the one
That's what I don't know.
the one he stole from Walter Bislin, did not give him credit for, put it on his own website, edited the source code, but you can only do so much. And of course, the source code includes the distance between the Earth and the sun of 150 million kilometers. It's in the actual source code. The radius of the globe, 6,371 kilometers, is in the source code. The angular tilt of the Earth, 23.5 degrees, is in the source code. So that really is just a globe model, and then it's just been warped to be on flat Earth. And then so again, the geometry doesn't work, because when you look at the path that the light has to take from the star or the sun to the observer, it's dramatically warped, and there's no plausible mechanism to cause that warping. So it's just dismissed because there's no evidence for it.
So they have a model, you're just saying. So the warp formula basically isn't consistent. I mean, if there's a consistent warp formula, I would be.
No, it's not a consistent warp formula. Yeah. And it's not just that there isn't a consistent warp formula. You need a plausible mechanism. Why would the light
I don't know.
take such an unusual path to go from the star to the observer, and turning in some instances, turning 180 degrees, going over the observer's head and then flipping back around to come back into their eyes to make the angle work right. There's no reason why that would happen. Refraction doesn't do that. It's not reflection that would do that. It's just basically magic has to happen. And I'm not of that kind of religion. Yeah.
That's over my head, but like I just kind of thought they put that little celestial dome thing in there, and they said the angles did work to the stars. So I don't.
They don't.
What you said was over my
I think for the most part is they're relying on people that don't have a strong background in geometry to be fooled by it. And if that was right, really, if I were a person that didn't understand geometry and found out that they're just trying to basically pull the wool over the eyes of people that don't understand geometry, I'd be a little pissed.
Could the sky not be a sphere?
All he's really saying, Don, with the plausible mechanism is we need to understand like why that happens. Like we try to figure out what's causing it. Really, that's just a
I don't know what it
scientific
is.
way of
But see, I don't know what
why would the light? Why would the light? Well, just like why would the light bend that way?
What light is bending what way?
In the path it would have to take. It's super dramatic path that the light has to take. Lots of bending, and right, we know the things that cause light to change direction. Refraction does it, but it's not a lot. You can't get a lot of change in 1 or 2 degrees is quite a bit. And then, but you need a dramatically varying medium in order for refraction to cause that, and there's no reason to think that sort of medium exists. Remember, then you've got reflection, which is where it bounces, and that's not the path that it's taking. It's not taking a bouncy path. And then the third way that it happens is warping of space-time, which is generally rejected by the same people. So that's off the table. So,
well, basically, to me, I just need to hear the stars are in the wrong positions. I don't know what light is bending and assume for all that. Either way, if there was some consistent formula that they could produce that would, tell you this is here at this time, it wouldn't matter to me why. I don't care why. I just care what's happening consistently, repeatable.
Yeah. Well, I don't have that kind of religion.
It's not a religion.
Yeah. Well, to think that light would bend in that kind of a way for no reason is a religious belief.
I mean, to believe stuff just came into existence for no reason.
I don't know what you're talking about.
I mean, I feel you, man.
Well, if you're talking about the Big Bang, I mean, all that science says is that we know that we can backtrace to a certain position of the universe prior to it expanding. So they're not concerning themselves with the why. They're just concerned with what happens, what we can measure, what we can extract.
No, I'm sorry. You have to know why. I'm sorry. If you like double speaking, then right? Go ahead and tell me that you don't have to know why. But if you like,
that's fine. You can say it. You can say that, Don. But the point is that science isn't concerned with the why when it comes to that.
No, MCToon just told me that science is concerned with the why. Though he just told me this, not here.
So I can clarify my position. So from my understanding, the claim of Big Bang and the hypothesis being that before a certain point in time, it's unknown. But after that certain point in time, it's not only here's what we are proposing with this hypothesis, and it's well supported, is happening, but there is in fact a why for many of it, for many of the different things. So you've got the electroweak force, and you've got this merger of different things, and different things were acting in a certain way. And so there is some understanding of the why, and they've done some research at high energy particle physics to understand the why. But before that certain time, it's unknown. And so it is the position of many theists to say, you know what, I'm happy with the prior to the Big Bang, God just said, let there be light. There's many theists that are like, hey, that's an awesome explanation. And I think the atheists are like, we don't know. We don't have a position. And, that's okay too. So are there...
what's your...
Yeah, I'll just ask quick.
What's your response? Yeah, go ahead. Sorry.
Just if there's any other Flattys that want to come up, just raise your hand and we'll get you in. Go ahead, IC.
Yeah. So Don, I think the point that Toon's making is we can understand how these mechanisms interact with one another, and we can explain why the universe is in the state that it is to an extent. But we're not going to make claims. In science, they will generally talk about theories that they can provide evidence for. There's always going to be speculation, and that's what science is. It's looking into hey, could it be this? Could it be that? Well, let's look and see if these line up with other things that we know about how the universe came to be, or other things that we know about how physics works. But we're never going to go and say science doesn't concern itself with the natural, the supernatural position is really outside of the realm of science. And a lot of flat earthers will take the term natural and they'll say synthetic is the opposite of that. And that's not the case. When you're looking at it from a scientific point of view, the dichotomy for natural, the correct term to create the dichotomy with the word natural is supernatural, is everything that's outside of reality as we know it. And that's the realm that science doesn't concern itself with. We only look at things that we can test and that we can measure and that we can use. We can make useful hypotheses to make predictions. I'm sorry, we can make hypotheses to make useful predictions for outcomes that are otherwise unknowable.
Yeah, I think that's a very common amongst flat earthers is the misappropriation of the word natural, and the opposite of natural is supernatural, not synthetic. In when scientists are writing about what science concerns itself with. So, and sometimes flat earthers even go so far as to define science or natural as anything that a human does then isn't allowed to be part for them. This is just very strange because the very same flat earthers also say that in order to do an experiment, the experimenter must, quote, wiggle the independent variable, unquote. Well, as soon as you have the experimenter do that, then by their own definition, that's not natural anymore. It's synthetic. So according to these flat earthers can't even do science because science contradicts itself. That's how weird of a definition they've intentionally made up for science. And the reason why they've done that is very obvious, so that they can reject any evidence that they don't like anytime they want. They can just say, no, that breaks science. Then they'll just go into some other aspect of science that they've all agreed upon is acceptable. While when they're like, oh, well, let's go get science for ourselves, and they'll take whatever they want, and they'll forget the same rules that they've applied to other things. They won't apply it to their own things. I see Lael has raised his hand, and Demok says he's here.
You can invite people even if they don't raise their hand.
Oh, that's true. I can. So, Demok had reached out to Riggs and said he wanted to debate me. And Demok, I'd love to. And the thing is, I think though, Demok, you need for you to be in a debate, actually, you need a bit more of a structure. And so the structure is that we each have 2 points, and I'll grab it and post it in the chat here. We each have 2 claims, and each of our claims must be positive evidence for our claim about the shape of the Earth. So, for example, if I was going to say the Earth is a globe, and then I would go and find I would maybe cite some measurements of the surface of the Earth and that it's curving, for example. And then Demok would have a chance, right? Then we have a discussion on that topic. And then Demok would have his chance to present some evidence supporting his claim about the shape of the Earth, right? That's a pretty normal way to engage in a debate. If you look at how Lincoln Douglas or Oxford or Mace debates are structured, that's what you do. You each get a chance to present your positive claim. You present evidence supporting that positive claim, and then you have a discussion about it. So, Demok, if you want to engage in that sort of debate, I'm absolutely up for it, and I think it would be a great time. But if you want to come in here to just say no dirt in the middle, I mean, that's funny, and we all love it, but that's not a debate. So, Demok, if you want to present, because the topic is the geometry for the claim about Earth measured flat, if that's what you want to do and talk about geometry, I'm in. Let's do it. Raise your hand and we'll pop you in here. Yeah, he says real physics aren't funny, no ball. You see, I mean, that's hilarious. It is hilarious, Demok, but it's not a debate. That's not how you debate. Yeah. Or not, you have no ball. The double negative, absolutely fantastic. Love it. Thank you for the double negative. Globe proven, I guess.
Double negatives always prove the globe.
I know. Oh, does he have his hand up? Maybe he wants to come up for a bit and present his geometry.
He does have his hand up. Should we bring him up?
Let's hear. But if it's not about geometry, then of Earth measured flat, then that's not really the topic.
Unleash the Demok.
All right, here it comes.
Has been invited.
There he is. All right, Demok, you I think you should be able to speak.
Hold on, let me see this. Can you hear me?
I can. All right, so can you show us how Earth is measured flat?
Yeah, that's what levels do, and rulers, and plumbs.
All right. Well,
A plumb shows you what horizontal is, right? Because when you have 15 plumbs lined up, with no one being higher or lower, or you have a line on the wall where the beginning part of it isn't higher or lower than the end part, that's a horizontal. That's what our Earth is, and that's how we measure stuff.
That's how plums
I have
work.
yet to see an Earth curve against my horizontal. Can you present a physical reality Earth curve on the wall against my horizontal or not?
So let's go through the geometry that you're talking about here. Can you run us through the geometry?
It's just draw a straight line on the wall. And then we need to run through what your curve looks like compared to that. Can you run us through what your curve looks like compared to that straight line with physical stuff on the wall, like the physical Earth curve? Can any glober please present physical Earth curve as a drawing on the wall or mud or a physical thing? I'm here to debate physical stuff. If you don't have physical Earth curve, you have no debate of any geometry because you can't draw what geometry you're trying to debate on the wall. So you have nothing. You've got a story with no line on the wall. You need that line.
So I need to draw a line on the wall.
Yeah, the Earth curve. Yeah, the Earth curve that doesn't exist anywhere.
Earth curve line on the wall.
Like, especially you. You're going to draw like a horizontal line. That's clearly not a curve. You're not going to draw the 8 inches per mile squared part. You're not going to keep squaring the function, are you? Definitely not going to know what that looks like. So nobody, especially you, can draw for any kids that you keep trying to convince that the Earth's curved. You don't know what that is. Put it on the wall. Print it out with a 3D printer. Make the Earth curve real 2026. Can we do that, MCToon?
Okay, so Demok, this was your chance to present the geometry for flat Earth. So I'm still waiting for it.
No, it's a straight line. It's a straight line, and put plumb bobs every single millionth of an inch next to each other for 1 billion miles all you want. They ain't gonna fucking deviate. This ain't a joke here, stupid. Stop being fucking jokey. You don't have an Earth
swear
curve. I'm here
on
looking for
my
an Earth curve
show.
that you guys can't present for 15 years. 15 years of not one glober being able to print out the Earth curve in a material, have a real globe map that has 100% of everything on it scaled down. Alleyways, grandma's house, the local store, gas stations, highways, road, everything, right?
I could tell you for sure that grandma's house was not level. It's a pretty old house.
No globe
It's
map.
a pretty old house, so it's not level.
Map that we can use to travel with exact distances that match distances that are straight outside somehow? Don't think so.
All right, so I'm waiting for the flat Earth geometry, everybody. Just go ahead.
Yeah, it's a horizontal line.
That's all you got.
Waiting.
That's all you got.
Water does. Yeah, I got water everywhere in your aquarium.
Do you have the horizontal? That's all you got.
Yeah, do you have the non-horizontal?
Okay, so
the changing slope plumb. Do you have the million plumb where you can
changing
show us
slope?
where they change rate?
Wait,
and drop below each other,
could you
but stay
define
plumb?
for us? Could you define?
Have any physical attributes? Stop asking for cartoon
I want
descriptions
no.
of
what is
nothing.
what is
Stop
the
asking for opinions.
what is the physical slope
Get
plumb?
to the wall.
What is
Your
what is
opinion
this
is on the wall with the earth curve.
physical slope
We can
plumb?
all go
I'm
over
confused.
it. Do you not want to go over the earth curve that doesn't exist? We're looking for the earth curve. If all you and I have is not earth curve on the wall, what are we debating?
So, Demok, what do you think about the new
no
the
earth curve,
the
what are we debating?
Artemis mission
What
going
does an
going
earth
up
curve
here
like you guys
in a
debate
couple
without
weeks?
an earth curve? What are you debating with no physical curve to talk about?
So, Demok,
Nothing to touch, nothing to
hold
put
on.
your scales on.
breathe for a
Nothing to
second.
move around, nothing to put your plums on, nothing to put your teeter-totter on. No curb water you can poke a hole in or stick
Okay,
out
hold
or
on,
in.
Demok, hold on. What is
What are we
this
all
physical
going to?
this physical
26 fucking-
slope plumb?
2026. This guy's holding on because he can't draw a curve. This dude's got math that he won't show us on the wall. Magic math of a globe that's just talking points. Stop holding on.
So, all right.
2026, make the earth curve
So-
real, not a talking point.
So,
make
Demok-
it not imaginary.
Oh my
Make it not a religion, MCToon.
Can you
we
breathe?
make your earth curve a non-religion thing?
Do you not need to breathe? So, what is
I
the
need
physical
you to
slope
understand what an
plumb?
earth curve
I
on
need-
the fucking wall is.
Do
you
not
need to
swear
comprehend what you're
on
talking about.
my
You
show.
just keep talking about imaginary shit you don't present to
Do
no one.
not
Draw it
swear
on the fucking
on
wall.
my show.
Loser with no curve.
Okay, can you
Who
just
can't print it
can you
out?
define
Your
for
3D
me?
printer must be
I
broke,
just
huh?
need the
Your 3D
definition.
Earth curve printer broke from LIGO.
I need
NASA
the
broke all of a sudden.
the definition.
The printer broke.
Demok, give
Is
him a
the
sec-
printer
give him a
broke,
second,
bro? Is the Earth curve
Let it-
printer
let it
not
speak.
working for you? Ask NASA. What do you draw on?
All right, Demok, I just need the definition for physical slope plumb. Just because you said that a while ago, and we're all just wondering, we're scratching our heads. What is physical slope plumb? Go ahead.
Nobody knows. You won't draw it on the wall. No one can ever know what an Earth curve is. You won't go ahead and draw it because you can't, because it doesn't exist. This is simple. There's no physical Earth curve to talk about, to debate, because it doesn't exist anywhere. I can draw a horizontal line all day for you, buddy. I can go to the hardware and get horizontal stuff all day. What does the Earth curve look like from a not function to your horizontal to the squared function that starts to square?
The not
Drop
function
down
to the
square.
square function. What is
Yeah, what
the,
does what
the
does that look
not
like on
function
a curve?
and the square
Yeah, what does that
function?
look like to a horizontal, the squared function of a curve?
The squared
The
function of a
dropping
curve.
function, 8 inches per mile squared. You don't know what that means?
You got to.
You don't know what squared means?
Okay?
You don't know what
Yeah,
it looks
let him
like,
respond.
that's for fucking sure.
Let
Or else
him
you could
respond.
draw
All
it
right,
on the
Demok,
wall.
calm down for a
Fucking
second.
talky
I
Lou.
want to mute.
You guys just want to keep talking.
All right, so
Okay, go ahead, Tim.
So all right, so here it is. This is I am on. I just want to point this out. I am here on a flat Earth Discord server, and I have on YouTube 400 people almost watching, and I'll have many thousands more watching after this point. And flat earthers, listen up. This is the one person who has stepped up. This guy. He is your spokesperson right now, flat earthers. He's the best you have. The best you have is this guy here who can't even stop rambling, and he makes no sense to anybody at all. I mean, it's comedy. This is absolute comedy gold, because this is the best flat earther that has stepped up right now. The top of the top is Demok. He is the king of flat earth. So I'll say, look, flat earthers, if you agree that he is your spokesperson, that he is the one to present in front of 400 people with thousands more to view after the fact, then you just sit back and you just love it. Just bathe in the Demok here, Flatties. This is what you have reduced yourselves to, that nobody's like, yeah, I will show the geometry for flat earth elevation angles, as has been claimed for years and years and years. I'll be the one to present that. Nope, nobody's got that. While somebody sits there every day making the same claim without presenting ever once the evidence, and no flat earther will come forward and present with the actual application of the measurements. And when the topic is bring forward the evidence, the application of the measurements, we get Democ, who one sentence in is on a different topic now. That's what we got. And what a
Democ,
bad day for Flat Earth.
What I'm going to do, Democ, is I'm going to unmute you, but what I want you to do is, I mean, that is the topic as Toon's provided. We want to know what you have to put your name behind to say that Earth is flat. So go ahead, all right?
A flat phone, a flat map, a flat screen, flat inches, flat miles, flat feet. They're all horizontal and flat. You don't need anything else, and they're all correct for what they are. So a flat inch is a flat measured distance. There are no curved distances to measure. There is no Earth curve. No one knows what it looks like. You can't touch it and feel it. We can all feel plumb. We can all feel horizontal and smooth and flat. We can all feel non-moving. But can you feel spinning and curve? No. The one thing we need for any of you guys to make any sense and to say you're the fucking globe king is an Earth curve that's physical on the wall. Not your imagination. Not looking at fucking dangles of an angle that you made up. I never met such a fucking retard in my life.
All right, Democ.
That keeps arguing he has something that doesn't exist. My ruler is waiting for your Earth curve.
All right.
Your miles
Give
of
Toon a
it.
chance.
Your 8 feet of it. Yeah. Go ahead. No curve, guys.
Give Toon a chance.
How are you going to present your fucking curve? Not by talking, hopefully.
Please don't swear.
Yeah, don't. My goodness. I mean, Oakley would never allow that. So yeah, I missed. It must have been my fault. I didn't hear actually any part where you presented the measurements of flatness. You just, like you said, flat screen, flat inch, flat mile, flat, a whole bunch of things. But and you said that you can't measure curved measurements. But here is a 70 centimeter cable. That is 70 centimeters long, and it's not flat. It's not straight. It is curved. So somehow humans have been able to measure things that are curved, at least since the dawn of USB cables. So again, so I don't want to take away the opportunity from any.
You can measure the table. That has nothing to do with anything we're talking about. We're talking about Earth curve. So since you can fucking measure the table and know it's not horizontal,
we're not
and you can
talking
draw
about,
that on the wall,
hold on,
right?
Do not swear on my show.
We're not talking about the Earth. The topic here is for you as the representative for Flat Earth to present the Earth measures flat measurements, the application of it, the geometry of it, so that we can attempt to rectify the claims that have been made for many years by many flat earthers. And so far, it's tough. Anyway, any flatties in the chat here, if you're in here saying, dang it, Democ, I need to show the real geometry. You go ahead, raise your hand. But I mean, so far, man, this is embarrassing for Flat Earth. But all right, I don't see anybody. Let's hear some more.
Well, he
talking to yourself and not drawing an Earth curve isn't helping you be the king loser you are with king nothing, fucking retard. Stop saying words of geometry.
Do not
when you
swear
have no Earth curve on the wall.
my show.
Your dumb loser ass needs to draw the Earth curve or else shut the fuck up.
So
you guys
Democ,
do nothing. You are the fucking losers. Red-faced, giggly fucking jokey boys who have garbage. You are garbage. Your IQ...
Democ, I just want to say I'm a lot smarter than you. And if you don't believe me, I'll put $5,000 on it. We can both take the same university physics test and winner take all. You don't like that. If you reject it, then you're just acknowledging that you know you're not as smart as me. Anyway, keep going.
What do you think about letting Lael have a crack at it?
Yeah, let's hear Lael. I think Democ can head back to the audience. So
okay.
Yeah, make sure you unmute him on the way down.
Yeah. Send. Okay. There you go.
Hello. I'm not a flat earther, but I got a really quick question for maybe Toon or Jesse or anybody else in here that wants to answer it. Can someone name a synthetic product that is not made from natural or occurring things?
Oh, that's a good question. Let's see. I've got a plastic bottle that's made of. Oh no, that's made from naturally occurring things.
I thought of rubber, but that's made from tree sap.
Oh, jeez. Man, my phone. Definitely my phone.
Glass is made from sand, which is naturally occurring.
Yeah, and what about the circuit board? That's totally not, right?
I don't know. You know more about circuits than I do. I'm not so.
The circuits are
I'm
made
guessing
from
it's synthetic.
they're made from silicon and doped with the boron and arsenic and other
Those are
things.
all naturally
Yeah, jeez. Yeah. You know, I think we got a problem here. It turns out everything.
And we can level it to what they tell us. But how do we know that we're actually measuring a globe measurement? Like, how do we know that our eyes aren't playing tricks on us? In other words, in perspective, how do we know perspective is not the answer?
Flying straight.
What's that, Don?
Until you do that, until you mutually exclude like the flat earth map on the macro fashion, like you made the funny video about, this ain't gonna come to end, man. But that's how you do it. You know that's how you do it.
I'm back. YouTube's back. It seems like there's a bunch of sites having trouble.
There we go.
Cool. Cloudflare might be being hit again.
So basically, where we were at is I asked Lael. I was kind of going through what would be a good way for a flat earther to go about showing measurements of flatness, and he was explaining about a theodolite and measuring level and.
No, I wasn't talking about a theodolite.
Okay, excuse me.
We're talking
about leveling tools that professionals use, like when we level, like the tabletop that I was talking about. It's leveled to a certain precision, right? You could do that on the ground. I don't know how. Now, this is where I get into Jesse, because if he's truly what he claims to be, he should know the answer. Jesse, for what distance could you do a leveling of the ground where you're leveling it all the way across to like a 20th of a centimeter? What distance before you start hitting a point where you can't do that?
What do you mean by leveling? Because in surveying, leveling means to establish a line that follows a level line, which is curved. So I'm not sure what you're asking. You mean how?
Well, like, for example, my tabletop is level, right?
In surveying, we would call that horizontal, horizontal. So I think what you're meaning to ask is how far could you extend a horizontal before it deviated from a level line by a millimeter or something, right?
Correct.
Okay.
Could I do like 10 miles?
Oh no, goodness no. That would be a huge deviation.
100 feet would be pretty easy, right?
100 feet, the difference would be very small.
What about, let's say, a quarter of a mile?
Let me calculate it for you.
At what distance do you start having to add in the curvature of the Earth to make that line horizontal?
It depends on the precision that you're looking for, of course. That's the challenge. You can't just answer an open-ended question like that. So it's probably more in to the point to that what Jesse is about to give you is in a half mile. What is the departure from horizontal according to the globe?
Right.
So
what I was saying, I did give a measurement, like a 20th of a centimeter. That's a measurement of how flat it would be. I mean, there's an error bar on each side of that.
A 20th of a centimeter?
Yeah. How far would you need to have that horizontal line go before your error bar turns into like 1 centimeter on each side.
Well, that's a different question. You're talking about the precision of the instruments versus the pure departure from horizontal in geometry.
Yeah, I understand that. If the Earth is measured flat, in this case, flat and horizontal would be a synonymous term, right?
Yeah.
So then Jesse says, well, you're talking about something being completely horizontal and measured horizontal. And I agreed with that, fine. I was misspoken. I didn't know that.
Yeah, sorry.
So if you wanted, okay, go ahead, Jesse.
0.22 miles would have a deviation of about 1 centimeter between the level curved line and the horizontal.
0.2 miles, yeah. Yeah, and that's you can measure that amount over that distance, but you need the right instruments.
So how would you make that horizontal line stay horizontal if it deviates by a centimeter at let's say it's a quarter, let's round it up to a quarter of a mile, because that's easier to think about math-wise.
Well, if you're going to talk about easier to think about math-wise, we should stay in pure metric. Right, not mix units. Yeah, but we're mixing units already. You're talking centimeters and millimeters and miles. So I want to make sure that before we go on here that we have we let the Flattys here know that they are invited to bring the measurements that are being spoken of when the flat earthers claim that Earth is measured flat, to the actual measurements, the numbers, the geometry, and for us to go through my presentation, which if you're just coming in, I took the actual measurements that I made myself in Minnesota at 45 degrees north, and in Pensacola, Florida at 30.3 degrees north, and in Puerto Rico at 18.5 degrees north, and did not find any concordance between the flat Earth claim of Earth measured flat and the actual application of measurements to match that. And I just posted again the graph of the angles to Polaris along with the flat Earth there. So if anybody has any interest in setting straight the claim, but so far nobody has, but setting straight the claim about that and providing the geometry and for how these measurements work, I would love that. And there are 2 people in my YouTube live chat that's claimed I did the geometry wrong, but haven't yet shown up to present the correct geometry. So just make sure that that's open for everybody.
Taking back, Eden, if you'd like to come up, just raise your hand. I mean, it's a simple, just back and forth, no pressure. I know that you've got some stuff you've shared with me recently. Might be good to kind of flesh it out. I don't have all the answers, so someone like Toon is going to have more, and it can be a cordial discussion.
Yeah, he scampered off.
He just left. Well,
and that, ladies and gentlemen, is not a good sign for flat Earth. Oof, tough days. How do you raise your hand? Yeah, there's a thing on the bottom of the screen there. If you're on a desktop where you can say you'd like, it's just a hand thing. Otherwise, you just type in the chat, I guess, and you can say, "Hey, bring me up," and we can just
invited them to come speak if they want.
Yeah, is that Tom Zig?
Yeah,
Von Vaxenstein
can accept. Should have an invite, Tom Zig.
Yeah, it might just give a little a thingy do whopper right there, notification saying, "Hey, would you like to speak?" There we go.
If he's an anti-vaxxer, you might not want him up
Oh
here.
yeah, that's not the topic. So I'm sure he'll read the room and note that the topic is providing the application of the measurements supporting the claim Earth measured flat.
So what you got for us, Tom Zeg?
Ooh, Demok is coming in with the zinger. How do skakes work on spinning Baljiks claim? Who knows how skakes work? That's a mystery.
Never thought about that.
Yeah, I'll be pondering that while I fall asleep tonight.
Hey, Vex, are you muted? Or are you hot micing?
Oh no, my bad. Yeah, I was hot mic, and I apologize.
All right.
Welcome to the show.
Hello, Jesse. How you doing? It's been a minute, man. I haven't talked to you in like almost a calendar year.
Wow.
Hold on a second.
All right.
I'm just getting used to like the way the setup is completely different than like what Discord looks like on my phone. So just give me a second. I'll go on mute.
All right.
So,
All right. How do skakes work? Huh.
Demok's got a bone to pick. He's
He
a
does.
little,
He does. Oh, he wrote spin
little
with two
angry.
ends. No scale. Yeah. I've never seen a flat Earth map with a scale that works. I think he's onto something there.
here, maybe he can help fill in the gap. So we'll give him a second look.
Yeah.
He's not gonna last long, but
No.
all right, what do you got to say, buddy?
Yeah, nobody can learn about the physics of a real ball, how you can weigh stuff on a spinning ball or what that would even be like, or how a spinning ball acts. They go to flat Earth.
Okay, hold on.
And they say,
Hold on.
flat Earth.
Hold on. I'll
we're
explain it.
not
I'll explain
moving-
it. I'll explain
on a
it.
non-moving
I'll explain
flat
it. I'll explain it. Thank you. Okay. So how do things work? What you do is you take a scale and you just set it down and then you put something on it. And when the Earth is rotating, that's okay, because even at the equator where you get the maximum centrifugal acceleration, it's 0.03 meters per second squared up compared to the 9.8 meters per second squared down that we get as a result of the effects of gravity. So it's a very small amount in relation to what the effects of gravity does for us. All right, there you go. There's the answer. Next question, DMOC.
That wasn't the answer. You didn't get a scale out and show any kids or any adults how stuff works on a real ball while it's spinning with a scale compared to outside.
Pause
you
again.
have no
Pause
physical.
again.
Stop talking.
So pause
over.
again. Pause again. Okay. So what you're saying is you want me to, rather than have it be sitting on the Earth, which is a sphere rotating, you want me to take it within the gravitational field of the Earth, which is significantly more dominant than any ball that I might get on within the gravitational field of the Earth, and then put a scale on that. Yeah. So all that would do is affirm to everybody watching that the effects of gravity work. So, all right, there you go. There's your physics lesson number 2.
That didn't make any sense. So you have no clue what a spinning ball does. You just keep declaring you live on one while you're on a stationary flat Earth. That's not how you do science.
So
Make stupid.
pause for a second
you
again.
get a ball and you
pause
say,
for a second again. Okay, so I do know how it's done, and so I don't know why you're saying that I don't. I just literally just explained it, and I don't know why it's so difficult. We didn't get through or something. Anyway. So since we do know that, I don't know what your problem is, Mr. Skakes. How do skakes work?
Yeah, can you explain how skakes work? That would be a good starting point, and then we can go from there.
You want me to?
Yeah, you go get a scale and you put it on a spinning ball. Then MCToon and every globe religious person would really know what a ball does. They don't trust balls. Balls aren't to be trusted in science. You can't get one and spin it and say that's what it's going to do, because that's a real ball. So the real ball debunks your fucking flat earth that you're standing on.
Okay.
So once you spin a real ball and put a scale on it, you'll see what they really do, not your fucking opinion, your religious claims about dog shit gravity and stupid fucking retarded claims you keep making religiously.
Please don't swear.
When you have no clue of what a real ball does with a scale on it. Put 5 pounds on a spinning ball, put 5 pounds on a stationary object. Trust.
Demok, one sec. What I'm going to ask you, Demok, I'm going to ask you what is it? Just take a breath, right? Just slow down for a sec. What is it that you want to ask? That it sounds like you got a lot to get off your chest, but pick one thing. Ask something about. Say you want to ask about 5 pounds on a scale. Be very specific about how that would help further your understanding about the globe. Okay, go ahead.
Because I trust reality, not stupid liars that say fucking religious claims.
Let me stop you for a second. That's fine. What I want you to do though is I want you to ask something specific. We don't need the insults flying off the handle right off the get-go. Ask something specific that'll help you further your understanding. Go ahead.
Yeah, I just told you, you guys don't know about reality. You keep making claims that you're.
So that's fine. You're making another statement. What I want you to do is formulate your statement in the form of a question, and then take a breath and allow for others to speak. Okay.
Yeah, I'm going to, you dumb bitch. Quit muting me, you fucking retard. Listen to the fucking end of my sentence before you mute me, you dumb fuck. I wasn't finished, you fucking retarded into fuck. This is how you have conversations, you fucking retards. Now, get a ball with a scale on it, or else none of you fucking cunts know what a ball does.
Literally,
don't ever fucking declare Earth as a fucking spinning ball.
I don't know enough about this stuff.
All right. So the problem is, of course, this is the flat earther that showed up so far. Pretty sad day. But anyway, Tom Zig, did you have any thing on the topic of the just the application of, or the demonstration of, the claim Earth measured flat? Like any measurements? I mean, that's what I'm here for. I'm just giving an opportunity, giving a stage to bring my audience the information from Flat Earth, because I don't think they've gotten it yet. I've asked, but I haven't yet received. So, and I don't know if Tom Zig wanted to participate or not, or
how do I get back? You're in the voice chat, bud. You're in the voice chat. All you got to do is unmute, and then you can cut her loose.
Yeah. I think, on the bottom of your screen, or if you're on mobile, it might be in a different spot, but you can tap a little thing to unmute yourself.
I think.
No, it's on his side. I'll have to hit the unmute.
Oh yeah, we can't force unmute.
Why don't you leave the app? Go ahead and leave the app and just jump back in, and we can pull you back up if it doesn't let you back on the stage. If all you see is texture. Oh, go to what you want to do is look for. It's called the ring, and you'll see it's populated with a bunch of people, and it'll say something about X amount of people are in the audience. Just click on that. It has a little trophy next to it with the little human icon. I think he's kind of wandered to a different room.
Discord on mobile is a nightmare. Maybe it'll be easier to pop if you just leave and then join back in, and the button will be there again. Maybe.
Here, I'll disconnect you, Tom Zig, and then just jump back in the room, and we'll let you back up.
All right. This has been very instructive, I think, so far tonight. Very, very instructive. If you in the YouTube chat there, if you have found this instructive, if you've learned something, or in the YouTube chat here, what have you learned? We got Alderbron says Demok, he's a bigoted, racist, vile, ignorant, and much more. That's what he's learned. All right.
Now, Tom Zig knows all about celestial navigation and angles to curves and angles to flat, and he knows all that stuff.
Nice.
All right. I'm going to invite him back up.
We got Call Badger Dude says meth's a hell of a drug. County Boy says all he's done is swear. RT96 says learned stay in school, kids. Canham Rock says we don't trust spinning balls. Red Cedar learned what he doesn't want to be. Yeah. Sharky has learned FA. Whatever channels says I learned about skanks and balls. I learned, the real Jiffy Cone says I learned Democ lost more brain cells than he last time he was here. He's been in the negatives for a while, but damn. Zebulon says I learned that Democ is destructive to the internet.
Oh, that's what broke it.
I think the skank comment might have been in reference to Oakley's little remarks. He likes to say chat skanking. And what's the other things he's? You know, it would be helpful if Buck Sodbuster. I saw him somewhere. He'd pop in here. There he is. Yeah, the interesting man in the world. Oh, okay, yeah.
Don't always share beliefs, but when I do, cellular biology is fake science. It didn't present very well on my screen because I have a kind of a custom setup here. But all right,
there he is. Maybe he might have the same issue that Tomzig has, where they can't unmute themselves.
Yeah,
I'm hoping that's not the case.
I can.
I'll have to call.
Oh, there we go.
Okay, cool.
Can you?
Are you on mobile though?
Is there some sort of issue?
Are you on mobile, Mr. Buster?
I just wanted to say.
No.
Oh, okay.
I'm on my laptop.
Mr. Tomzig was having problems unmuting. I think he was gonna enlighten us with something, but yeah, just.
Well, Mr. Tomzig just told me I'm doing good. I'll be right back.
Demox's balls are cremated. I guess that's the case for should somebody get cremated, that would be part of what gets cremated. So
yeah, that's a subset of the human.
Yeah.
Overall, I think. Yeah. Mm-hmm. Good point. Again, I think Arnold he's shy right now, but I think he might say that's a good point that he had not considered yet.
Whale Panties has learned, the majority of really stupid people I have met are too stupid to be miserable. So why are flirps such douche canoes? Ace Radio says stop eating crayons, Democ. But now, so Riggs had asked in the questioning about, have we had a debate? As Democ wants to debate. He asked, has Democ ever had an opportunity to present his case? And I think he's had many opportunities, but I want to be fair. And so let me get the format that I propose. And so this would be, what do you think? Would it be really cool to have like a Democ actually participate in a real debate where, like not just the kind of kicking the can around kind that we do here on YouTube, but actually like a real structure. I modeled this after.
Look at that,
Mace.
He wants to do it on physics, Toon.
He wants to, physics of a ball. So now remember, Democ. Remember when you made when you suggested that you thought that you were smarter than me, I gave you an opportunity to pocket a whole bunch of money. I will put $5,000 in escrow. You put $5,000 in escrow, and we both take the same university physics test. Winner takes all. We'll live stream it. We'll get a proctor. I'll cover that. Out of my pocket, I will cover hiring a proctor for you and hiring a proctor for me, and we'll live stream both of them, and then winner take all. Same test, should be good, since you think that you must be smarter than me by the insults that you've leveled against me. And if you don't accept it, well, we know why you would not accept it.
Well, if it's a formal debate, are you also going to subsidize the purchase of his top hat and monocle?
No, this was just about a different topic than the debate, because he tried to insult me. He tried to say that he thought that I wasn't as smart as him, and this is that topic for him to demonstrate that in reality, if you think you're smarter than me, Democ, let's do it. Let's go take that test and see who's now. I have to say, Democ, I'm a bit rusty. I've not been in university for a few years, so you may be a little fresher than I am on it, and I'm willing to take that risk.
Look at that. He's betting 50,000 to your 5,000.
Really?
Yeah, it's 50,000 to only be smart as pencil. It's a pretty good bet.
Wow.
Is it 50,000 of your own money, or are you like Mikey Smith? He went to a car dealership and he was going to bet one of their cars that Earth was flat. But as long as it's 50,000 of your money and you're willing to put it in escrow, we can draw it up.
Only be smart as a pencil. I'll bet 50,000.
I'll take 50,000 of Toon's money and put that in.
Bet 50,000 little puss. That. He says, "You're dumber than a drawing of curve you talk about. Draw an Earth curve. I'll bet my 50,000 against 100,000 of yours." Well, why would I do that? That doesn't make any sense.
He wants to bet 50,000 of his Earth curve against 100,000 of yours.
No, he
How
wants
do you do that?
He wants a unbalanced bet.
Now here's an easy $50, Toon. He will bet you $50 that you can't draw. Basically, I'll read it out and then I'll say what I think it means.
Okay.
You can't demonstrate a real ball matching Earth and a drawing on a wall. I think what he wants you to do is draw the Earth on a wall, and he'll give you $50. I mean, that's easy, right?
Yeah.
We could put it in escrow.
Yeah, I needed an escrow, of course.
Yeah.
I want you to draw a scale version on your wall.
A scale version of the Earth on the wall?
Scale.
To scale? Okay, that's going to be.
You mean a 1-to-1 scale?
The size of Jupiter?
Do you mean a
1-to-1
hold
scale?
On. A 1-to-1 scale. So not to scale means you haven't yet specified the scale.
That's a good point.
1-to-1
of the Earth.
Yeah. Yeah. So Earth curve on wall, 50,000 of Earth curve. Yes. How how does that even make sense?
I can't.
Well done, Democ. You have humiliated flat earthers again.
50,000th of an Earth curve on the wall.
Maybe that's it.
Horizontal line.
Is that what he means? Amazing.
Yeah, I guess so. 50,000th of an Earth curve would be a straight line, right?
I guess so.
Sounds like
fascinating with when the wall became so important.
Lael, anytime we have questions about what Democ means, we're going to ping you.
I think that's he is the Democ whisperer here. 50,000 to
Earth curve scale. You should know that.
Well, he says no, 50,000 to draw an Earth curve and prove it with 2 O's. Well, cool. Tell you what, write up the contract, the acceptance criteria. Put that money in escrow.
I want you to make it in mud.
And there you go. Anyway, so here is the debate format that I would love to see Democ participate in. And yes, I will send him a top hat and monocle if he would want it. He would have to give me a way to deliver it to him. So Alex Strand says
an Amazon. Go ahead.
Alex Strand said, "Did Democ just say that balls can't be trusted, and the real ball debunks flat Earth we stand on?" He said something like that. It's difficult to really put meaning to what he says.
Got any ideas, Lael? Is that what he meant?
Yeah. What is that mean?
Yes.
Got it.
Okay. The answer is yes.
Perfect. Cool. All right. I got a couple super chats to read while we're waiting. If there's any flatties that want to come up and present measurements, you raise your hand. Leslie Horner says flat Earth measurements, ROTFLMAO. And I believe that word is pronounced Rotflomau. There it is.
Yep.
Earthly Skeptic says, who's feeding back? Who's listening on speakers? Shame on you. Earthly Skeptic says, will they say measurements need horizontal plane? Well, that they may, but that is a begging the question fallacy. Because what they're doing is they're saying that the begging of the question is that when you use a plane in your measuring instrument, that the plane is automatically and magically and somehow matching to the Earth and necessarily matching to the Earth, but there's no connection there. There's no necessity in logic or in geometry that if you use a straight line or a plane when you're taking a measurement, it doesn't need to be concordant with any particular physical thing. It could be, but until you actually establish that relationship, you don't know, right? So that's the whole thing. The ending of the measurement will then tell us whether or not the Earth is flat. But they've taken that and they've begged the question all the way back to the beginning, stated their conclusion in the very first question by saying it requires a horizontal plane. No, it doesn't. That's the ending of it. We're questioning whether or not we will have a horizontal plane. So it's a perfect example of a begging the question fallacy. It's a Rubik says, do they ban evidence like on Oakley's server? No, I've been sitting here for an hour and 40 minutes asking for people to present evidence. And so far, I've had the opposite experience of Nathan Oakley ever has. When I've watched, or I don't always watch, but when people show up, when Globers show up on Oakley's server, Oakley's stream, this has been the opposite. We've asked people to come. We've asked them to present their measurements. Now, Democ, he's a bit of a, he's a comedian. He is instantly off topic and just, vile and vulgar and insulting. And I mean, it's basically Nathan Oakley might as well be here. Hawk Rum says it's flat because word salad. That's Democ a bit, yeah. Lord Illuminous Poo says making claims without good reason isn't a positive. Most people call it a negative, like with my hunchback, pigeon toes, large nose, and enormous member. Oh, look, it's Democ with money. Oh, that's precious. It's so cute. It's so cute. Tim Davidson says, silly flirts, the opposite of natural is supernatural. The opposite of synthetic is organic. Tim Davidson says, I used to drive a Geometro. Oh my goodness. Is Taylor?
Is Taylor up? Yeah, I'm gonna invite her up. Well, she hasn't responded to us.
Yeah, well, I mean, we got a topic. I want to stick to that topic. Icy Spin says the Democ is spitting hot fire, baby. He does. It is hot fire. It's hot something, maybe. Yeah. Hakraman says try showing 3D reality with a 2D drawing on a wall is flurf stupidity. It is, but it's the kind of flurf stupidity that Democ brings. Evil Producer 1 says never go full Democ. You went full Democ. Yeah. Tim Davidson says, dimmest mock, I will provide you a bucket of gravity after you provide me 37 pounds of the smell of pizza. Oh, Democ, please, I want 37 pounds of the smell of pizza. That sounds fantabulous. Tori Hanzo says Democ ate too many crayons and now he can't draw a curve on the wall because no more crayons. Ah, and he's gonna have Technicolor poo for weeks too. Oh, did he say no earth curve in mud? Jack Fetter says, when did Democ develop a lisp? That's a good question. Democ, when did you develop a lisp? I think we need him to come up and answer. When did Democ develop a lisp?
Goodness.
No,
I believe there's one known photo of the Democ, and Arnold is really.
I thought there were.
I thought
there were two. Hold on.
There might be two. There might be two.
Let me give me a second here. I'll
This could be helpful to his 3D model of Demok. Harold would be highly interested in that.
Well, the first place to check is, of course, the Flurp Wiki. There should be any photos of Demok should be on there.
Is Swingfish a flat earther? They are asking to come up.
Swingfish. I don't know. Let's they got their raised hand. So the just I don't know if Swingfish has been around. I'll assume is pro flat here, and the topic of the day is to put actual geometry behind the claim of Earth measured flat. So take actual measurements. I gave a couple, for example, and then to just walk us through the geometry for flat Earth and how you would then conclude that Earth is measured flat. And Demok is Demok, the Facat phone and the Facat computer. You guys don't 3D flatty boys flat screen Facat phone Facat computer. That is
remarkable.
It is. It made me cry inside. Icy Spins says Demok is in the booth right now writing lyrics. Zoomicide says, here's my exhaustive list of everything I've ever learned from flat earthers. And then, your comment got cut off. There's nothing after the colon. That had to be a mistake. Evil Producer 1 says, when MCToon fails Demok's challenge, just deliver the winnings to the nearest crack house. Did we get Swingfish?
Yeah, I'll let him
up in this place here. Here we go.
There he is.
Oh, hey. I'm not a flat earther.
Oh, all right. Well, it's a bad day for flat Earth then.
I have one suggestion, a real quick one.
Okay.
They're riding this measured flat wave pretty hard since TFE. So, but nobody actually show how this can be done.
Yeah. It's been over a year, and they've been saying it for more than a year, but in an entire year, not one flat earther has ever shown the geometry for that. It's almost as if it's a religious mantra. Somebody looking in from the outside might see flat earthers making that claim and then conclude, wow, that's just religion. Huh.
It's pretty funny how this is becoming a scream show every time.
Oh yeah. Let's see.
Well, maybe not go too much on the geometry because they clearly have some problems with that. Maybe just ask them for how they would actually do that physically.
Well, but they're the ones that know geometry better than all the scientists on the globe, right? Because they're the ones that say Earth is measured flat, so they must have the geometry for it, or they wouldn't. I mean, that'd be embarrassing for them to say such a thing and not have actual supporting evidence for it. I mean, that'd be ridiculous. That'd be so embarrassing.
Yeah, that's true. In the last Scream Fest with Oakley, there were a few moments where he just screamed it out like what he is always screaming out. And then if somebody would just say, okay, let's just do that with a tail light as example, but you are standing on a hill.
Yeah. Well, you wouldn't get that far with Nathan Oakley because he'll mute you first. And yell over you and swear at you a whole bunch. And then he would wind it up with this one.
Now I'd like to know how my balls taste.
But all you need to do is ask Neil, and he'll give you in detail the answer to that question. Nathan even has gone so far as to claim that a mile can only be flat. Like I showed, I showed earlier.
Excuse me.
Let me see here.
Yeah, don't they know that that rulers are not by default straight or flat? I mean, I have a measuring tape here. It's clearly not straight or flat.
Yeah. So here is, I'm posting a 70 centimeter long USB cable, which is certainly not straight. So I don't know how in the entire flat Earth how that could have been measured, because it's not straight. Did it, maybe when it's no longer straight, it loses the feature of having a length, right? Maybe that's
a quick question. Yeah. How so we've been talking about flat Earth measurements and flat earthers, providing something that would be substantial for us to examine. What would be something, as a glober yourself, what would be something that would cause you to go, you know what? I think they might have something.
Oh, that's easy. Yeah. So there's a lot of things.
Well, swingfish.
Swingfish. Okay.
Swingfish.
Yep.
Yeah. Got any ideas, swingfish?
That's a good question. That's a really good question. Hold on, I had something in my mind a few days ago.
All right. While you're thinking of that, Wild Lee Coyote says, "Has anyone flipped because they were insulted?" I don't think so. Slithery says you need to start using RFC 1149, which is one of my favorite RFCs. And if you don't know what I'm talking about, just type in RFC 1149. There you go. Oh, Buck Sidebuster. That's a screen capture from, I'll take your word for it. I can't recall it, but from his intro video of, how was that obvious non-flat road measured using miles? That's impossible, according to him. There must be something that we're missing in that. We've got Andreas L in Sweden for 50 sex, which is a good amount of sex. Says if you remove all the swearing and insults, does Demok really say anything at all? No. No. And no.
I had a question for you, Toon. If Swingfish is still waiting, I don't know if you have something else to read, but
okay.
So I watched a good deal of your recent videos of all the evidence that the Flirts are happy to look at, of course. When you guys were in Punta Arenas and Antarctica. And one thing that crossed my mind, and you may have covered this at some point during the video, but it was when you guys were in Punta Arenas. It was you and Critical Think, and I know Dave was there, but you guys were doing what jogged my memory was the photograph that Buck posted, where it shows the surveyor walking with the wheel,
the trundle wheel.
You guys measured the trundle wheel. Yeah, you guys used a trundle wheel while you were there, and you guys were, as far as I understand, you guys were measuring the radius doing that. Is that accurate?
We were measuring the distance between lines of longitude. That was our thing we were measuring. So
and what was the hypothesis that you guys had, and kind of what was your approach to that experiment?
So we had two hypotheses, one for flat Earth and one for globe. The globe hypothesis is to take the at a certain latitude. If you follow a certain latitude for a portion of the circumference around that latitude, so that latitude on a globe is a small circle. If you follow that for a certain percentage of it, then you can multiply that then by the entire percentage of it to get the entire circumference of that small circle, or the distance between lines of longitude, at that latitude, or simply for the starting and ending locations, how long does what's the length that the globe predicts? And then similarly for flat Earth, what is the percentage all the way around? What is the circumference of that circle, or more specifically, what is the distance that the flat Earth predicts between those 2 points? And this was actually proposed by Jesse, who's here in the chat with us.
Hello.
Oh, great. I didn't know that.
Yeah, so
that's cool.
I was hoping when I first thought about it, I was hoping maybe we could actually measure an entire one line of longitude difference, but we were significantly too far north to even do that. At 79.5 or whatever we were at there, latitude and south.
And so y'all had a prediction of basically how, like, y'all were going to walk a certain amount of trundle wheel steps or whatever. I don't know exactly what y'all call that, but then you can allocate that to this is what the amount of miles that we walked, and at this latitude, we would expect that to be this amount around a globe, or what?
Yep.
What kind of was the approach?
Yeah. So
that pretty much that. Okay.
It is. It's one of the experiments that I wrote about ahead of time, and I think it's one of the best. I think it's because it is a really solid prediction that you can make for either model. And it doesn't matter if you're going to say, oh, well, we think that it's the dual pole model. Awesome. We can do the same thing with that as well. So which one is it here? It is number 8. And so on there, I gave the formula for the diameter, let's see, the arc distance for the globe. And I gave the distance. I gave both formulas for flat and globe, and then I computed the distance between lines of longitude at Punta Arenas and Antarctica, and of course we didn't do that entire amount. We did a percentage of it. So the where we were in Punta Arenas, the globe is 67 kilometers between lines of longitude, and for flat Earth, it's 277 kilometers. So since they are so significantly different, this is a really good test because they're nowhere near each other. So it's not like, oh, we didn't have very precise measurement. You don't need to have precise measurement to really have a solid differential there.
Yeah.
We did it in Santiago as well. And I still haven't dug up the actual numbers. We didn't use the same method. We didn't have the trundle wheel, so I didn't like it as much.
And what were you hoping to do with the I forget, the apparatus that you brought that broke on the plane? You were going to do an experiment with that?
That was a dip compass. The dip compass measures the magnetic inclination. So when you are near the North Pole, right, about, approximately the northern hemisphere, the angle of the magnetic field of the Earth is north end of the needle down and the south end of the needle up. That's because the North Magnetic Pole is inside the Earth and directly south of what we call the North Magnetic Pole, which is somewhere near the North Geographic Pole. And then similarly, the South Magnetic Pole is actually not over Antarctica even. It's over the ocean between Antarctica and Australia, pretty close to the Antarctic coast. But when you're in the southern hemisphere, the south end of the dip compass will point down and the north end will point up, according to the globe. And so that was the other prediction then, because the flat Earth, where they have either just a single North Magnetic Pole, and they're completely blitheringly unaware that there is a South Magnetic Pole, it wouldn't work very well because well, it would be differentiated very well, because the north end of the needle would always point down, but it would point down less and less as you got farther south.
And it's just based on the difference in the strength between the two, right?
No,
That
it's
would
the
cause that
angle.
needle to-
It's the angle, not the strength.
Oh, okay.
So I also measured the strength, because how far you are from a magnet, the strength of that magnet will decrease as you get farther away. So the globe makes a certain prediction. At least we can make a qualitative prediction about the strength of the magnetic field for both globe and flat. Globe actually produces numbers, flat does not. But you can at least say, well, when you're farther away from the pole for flat Earth, then the field strength must go down. So the magnetic field strength must be strongest in Minnesota, and then weaker in Miami, and weaker in Santiago, and weaker in Punta Arenas, and the weakest in Antarctica. But I found the opposite. I found that it was not the opposite. I found it was weakest in Santiago, and then it increased when I got to Punta Arenas. It increased again when I got to Antarctica, which is what the globe predicts. So once again, we have another prediction that the globe made, and the flat Earth made, and the globe was confirmed, and the flat Earth was not. And no flat Earther in a year and some time has addressed the topic. The best I've gotten to addressing the topic was you didn't post the measurements. So I posted the measurements again. And then you didn't post the video of the measurements. So I posted a video of me taking the measurements. And then when I handed it to them, they just shut up and walked away, because now they have nothing. These were all just fake concerns, right? They're like, oh, I'm going to bring up something instead of the actual topic. I'm going to bring something else up. Because if you think that the numbers I wrote down were incorrect, boy, wouldn't it be humiliating if you actually went and did those same measurements and found and then exposed the lie? Go do it. But no, the baseless accusation is all they ever want to do.
Well, I think the funny thing is that it just exposes them as not understanding the topic, right? Because they'll bring up something that they think is a dagger.
Yeah.
And you'll have an answer for it. And when it's the second that they change the topic, it just shows the lack of confidence in a rebuttal.
Yeah. Is paraplegic?
He's a flat earther.
He usually has a lot to say.
Yeah, there we go.
I mean, I'll invite him up.
Paraplegic, the topic here is the putting actual geometry to the claims that flat earthers have been making for years of Earth measured flat. I've never seen these measurements. So just, opening up, just asking, giving a stage, a platform for flat earthers to bring forth these measurements, the geometry for it.
Paraplegic, this is a one-on-one, right? You come up, nobody else is talking. Obviously, Toon and I have been going back and forth because we're just kind of idling right now. So it's not a dog pile. Nobody wants to attack you. It can be a casual conversation. So. Swingfish, did you ever think of the question that you might have had for flat earthers?
No, it wasn't really a question. What I usually do is I agree with them. I mean, on the surface, just to be more on the friendly side, and then make them explain it. Like, oh yeah, that makes a lot of sense, but I do not really understand that. And then, but yeah, this usually ends in very, very big silences.
Right.
All right. Well, I got a few things here. Rossi says DMOC is the smartest flurf. He acknowledged Plum, which is legitimate reference available everywhere, from which the theoretical local flat plane, which Nathan loves, can be derived anywhere. Yup. You can't level a theodolite or auto level or transit without using the vertical vector. That vertical vector is the only thing you actually have. You don't have any reference to horizontal in a theodolite. You only have the vertical vector. So all vertical measurements are actually relative to that vertical vector. It's the only thing you actually have. So if you are in a spot, say you're near a mountain and the mountain has a large mass and it's deflected the vertical vector, that's an issue. And you could have it be at, maybe 1 or 2 arc seconds off, I suppose. I don't know the exact amount. And so you'd need to be careful of that if you were near a mountain while doing that surveying and needing that kind of precision.
Tomzik, you are back up on the stage. If you can find the unmute button on your phone, you should be good to go.
So a paraplegic
drunk debunk hanging out
appears to have his hand up, and I've hit invite to speak.
No, I think that's what that is. It's the green one when you see it green.
It's been invited.
It's initiated by a speaker. Yeah.
We got it. Okay.
Then it's on them to click
accept. Okay, I just want to make sure. I just want to make sure he feels welcome.
Are we maxed out? I don't know if can you fit more than 9 up here, or we have 8, I guess.
Oh yeah, because
I think it's fine. I saw the Crunk Debunk hanging out. He and I had a little bit of fun. Yeah, I say the Crunk Debunk. It's Drunk Debunk show.
No, it's Crunk.
Mike.
It's Crunk. What are you talking about?
Okay. Maybe he can speak.
Tomzik, you're unmuted now.
Last night, and I thought that we kind of bled that well dry over on QOP server. That was kind of fun.
That was a good time.
It was.
You know what triggered him, Toon, and Mike can tell you. Mike decided that he was going to read a book to them. You want to go ahead and tell them about it?
Yeah, I read the great novel.
What?
It was called Rocket Science for Babies by Chris Ferry.
Oh, that's such a good one.
Yeah. I got to tell you, it really triggered him.
It ruffled
Speaking of rocket science, I'm finally just letting myself just a tiny bit get a little, I don't even want to use the word anxious. What's like a word that's 10% of anxious? Whatever that word is, I'm getting
concerned.
that word about the Artemis launch.
Yeah, concerned. I think Mike said it.
Yeah.
Well, they're ready for it. I mean, they
rolled it out.
They're good to go. Yeah.
So I don't know. That'd be amazing.
I bet their CGI department is probably they probably subscribe to like Amazon Web Services, and there's been a lot of issues with Verizon, and some of the servers crashed earlier. I mean, Toon, you had to reset. Who knows what's going on with the internet? So the CGI might just be taking a break. They're not sure if they're going to be able to pull off the fakery, in conjunction with what they're proposing is real.
Yeah, because if they were gonna fake it,
sorry, I guess
there'd never be a problem. They just do it, right?
Hey guys.
So all right, Rig says Brian Leakey, who goes by Flat Earth Tests on YouTube here, says, how is magnetic declination determined where you guys took your distance between longitude measurements? And then Brian Leakey might come on if he can present. Now the topic, Brian, if you want to present, absolutely you can. The topic is showing how Earth measured flat claim is actually, made concrete. Where is the actual measurements of it? What's the geometry for it? That's the topic, Brian. I'd love to have you if that's what you want to present on. The question, how is magnetic declination determined where you guys took your distance between longitude measurements? There's the World Magnetic Model. The World Magnetic Model is based on real physical measurements all over the Earth. They do it constantly at certain fixed stations. And there's also some different stations that they every couple of years they go to measure the South Magnetic Pole. So a ship goes out and they do some precise measurements of its location and strength and angles and all that. So anyway, so they take all of these measurements at fixed stations, which is going to include this total field strength at that location, as well as the vertical and horizontal angles. And then they use that to then develop a model for that you can use to get a prediction for any location on the Earth. So it is modeling, and that's how you actually test a hypothesis. You build that model, then you go test it, and if it works, then you know that your model has some accuracy to it. But when we measure our distance between lines of longitude, we did not use magnetic declination or magnetic compasses. We used GPSs, and we had already determined that GPSs were accurate. This was a really cool way that we did this. We went in Punta Arenas. Critical Think had the GPS receiver, and we put a mark on that concrete platform there that was overlooking the ocean. And then he walked on the same line of longitude straight south. And he went way out straight south. And then I drew a line using a rock, just scratched into the concrete, a line on the surface of that platform. And from where I was, just eyed it to where he was. And that gave us approximately due south. Now, that was just using GPS, but was it correct? Well, we tested if it was correct. By waiting until local solar noon and then putting I used a tripod right on that line, and the shadow went straight on that line, confirming, because that then is a measurement of due south. Right? Local solar noon in the south, when you're south of the GP of the sun, the shadow goes due south. So the GPS was 100% in agreement with nature. So we then are confident that we can use the GPS to determine north-south, and that we can trust it for location. So that's what we did, Brian Leakey. There you go. Let me read. I got Lord Illuminous Pooh says curve is stored in the balls. Yeah. Tim Davidson says, today I learned sharks are a species are 4 times older than the rings of Saturn. Extra fact, horseshoe crabs have made it 2.5 times around the galaxy. Oh my goodness. That I did not know. I'll take your word for that. I'm not going to go confirm it now. Mr. E-Man Original says, what did I miss? All of the flat earth evidence? No, all the flat earth evidence equals the square root of -1, which of course is imaginary. Okay, I got a few more that I missed. But we didn't get who's going to come up here? Nobody came up.
I think we were waiting on Leaky.
Leaky might come. Tom Zig was getting stuff figured out. I think
he did. I think because he did
I heard him
unmute
talk.
himself. Oh, he's back. Look, he's back.
Yeah, awesome.
Yeah, I unmuted myself, but other people were talking, so I just put myself back on mute.
All right, so we're curious if you can help rectify the claims of Earth measured flat with the inability for anybody to actually show the geometry for it.
Well, first off, I would like to define our terms.
Okay.
Can you define what an elevation angle is, MCToon?
Okay. Sure. Elevation angle is the complement of the zenith angle. The zenith angle meaning that 0 zenith is straight up. 90s.
Where are you reading this definition from?
This is the surveyor's. Yeah, this is surveyor's. Introduction to Geomatics by Galani. You can find out PDF online if you want. So zenith is straight up, and then the departure from zenith in degrees is the zenith angle. 90 is horizontal at that location only. But typically when we say elevation angles, we flip it. So we take the complement. So then horizontal is 0. And then as you increase in elevation towards zenith, you're increasing your elevation angle. So if you're reading an elevation angle of 30, that'd be a zenith angle of 60. So that's the definition there. That good?
Go ahead, Tom Zeg.
No, that was a horrible definition. What are you talking about? Is that good?
All right. Well, could you have a citation that's different then? All right. While you're thinking about that, Evil Producer 1 says DMOC doesn't have a lisp. He has a mouthful of Dick Waynes.
Tom Zeg, the floor is yours if you want to provide a different definition that you want to work with, or if you have a criticism about why Toon's surveyor definition was inaccurate.
Well, I asked MCToon for an elevation angle definition.
Yep.
What? Say your definition one more time for the class, please.
The complement of the zenith angle is the quick one, short, the terse.
No, I'm not talking about zenith angle. I'm talking about the definition for elevation angle.
Yeah, the complement of the zenith angle.
No, elevation angle. The definition for an angle of elevation, please. Not the complement angle, not the co-altitude angle. The angle, the definition for an elevation angle.
Yep, the definition for the elevation angle is the complement of the zenith angle.
Citation.
Introduction to Geomatics by Galani.
Can you post in the chat so we can look this up?
Yep. There you go. So did you have a different definition? Some other definition of elevation angle?
I have the actual definition of what an elevation angle is.
Okay.
I'm going to go to the text chat and see what your citation was. Hold on a second.
So I gave you the book, in Elementary Surveying, an Introduction to Geomatics, 13th edition.
Notice how I just want the simple definition for an elevation angle.
Oh, I can.
And you're sending me the entire book.
I can do that for you.
I just want the simple. What is an elevation angle?
Yeah, it is the complement of the zenith angle.
No, what? No, not the complement of anything. What is an elevation angle?
Okay, so when I say complement, it means 90 minus. Did you know that?
No, what is an elevation angle? The definition for an angle of elevation.
Yeah, it's the complement of the zenith angle.
No, what is the definition of an elevation?
I already gave it to you.
It's not a hard question. It's not a trick question. It's very simple.
And it's not a trick answer.
What is the definition of an angle of elevation?
And it's not a trick answer. The answer is the complement of the zenith angle.
Tom Zeg, all he's trying to tell you is that you get your zenith, and then in order to measure the elevation angle, you take the complement of it, right?
An elevation angle is the upward angle between the observer's horizontal line of sight and the line of sight to an object above the horizontal plane.
Okay, yeah, that's the same as the complement to the zenith angle. The exact same number.
The complement. No.
Yeah, it's the exact same
I'm
number.
asking for the definition for an elevation angle, not the complement of the elevation angle. What is the definition of an elevation angle?
The complement of the zenith.
Notice how you won't say it.
I already gave you the answer. How many times do I need to give you the answer? It's the complement of the zenith. See, the thing is,
I'm not asking for I'm not asking for the definition of the complement of the zenith angle. I'm asking for the definition for simply a very humble angle of elevation. What is that definition?
And I can give that to you if you refrain from interrupting me while I give that to you. Can you do that?
You have yet to present that to me, sir.
Can you control yourself enough to not jump in while I'm giving you the definition?
I'm perfectly fine.
All right, you ready?
Here comes.
Here comes.
All I asked for. Hold on. All I asked for was the
you're not letting me. You're not
elevation.
letting me give it to you.
Oh, okay.
So what you're going to need to do is have some self-control there, little boy, and you're going to have to let me talk. Okay. Obviously, I know more about geometry than you, and I'm using words that are a little bit beyond what you understand. That's fine. I'll make it a little simpler. So
the complement of the zenith angle is the definition of an elevation angle. Really?
Oh. Settle down, little boy. Okay. So when you're using a theodolite, you have the only thing you have as a reference is vertical. That's why they start with zenith being 0, vertical. And so horizontal then is the orthogonal plane at a certain point, orthogonal to that vertical vector. So when you said horizontal line of sight, right? So you can have a horizontal line of sight, which is orthogonal to that vertical vector at your elevation, wherever your eyeballs are. Right. And so that is 90 degrees. When I say orthogonal, then you should probably know 90 is what that's meaning in this instance. And so you've got your 90 degrees, and then you can move from horizontal up to say 30. Right. And so just like I said before, that would be 60 zenith, 30 elevation angle. Elevation angle is raising up from the horizontal, and the horizontal is 90 from vertical. Again, that's the complement. So when I say the complement, that's what the horizontal is. Okay.
So, yeah, try to have a back and forth. I hate muting people, and I very rarely do it. Just try to have a back and forth. Try to be respectful of one another. Keep the energy down. I know you're passionate. I know Toon's passionate, but let's try to keep the energy down and have a conversation. Okay, go ahead.
Yeah, my bad. MCToon, what is the definition of an elevation angle? Just an elevation angle by itself, not the complement of a zenith angle. What is the definition of an angle of elevation?
Okay, I'll keep it simple. It would be the angle between your horizontal line of sight, as you said, and the object that you're looking at. That's fine. That's a fine definition.
Why didn't you give me that in the first place?
Because I gave you the more accurate one to start with. More precise.
No, you didn't. You started talking about the zenith angles and stuff.
Let's move on with the definition he provided. Go ahead, Tom Zig.
So, just to be clear, MCToon, your definition of an elevation angle is what now?
The one that I started with, of course, has not changed. The complement of the zenith.
I didn't ask for the definition of the complement of a zenith angle.
Okay,
I asked for the definition of an angle of elevation.
Look, it's clear. It's clear you can't address this topic here. This is beyond your comprehension. It's too bad.
That's an ad hom.
Listen, Tom Zig. He gave you a definition
that's literally an ad hom.
Wait a second. He gave you a definition you can work with. He said it's the elevation between the horizontal. Let's go with that. What do you have to say about that? Let's not rewind. Let's not get into the meta. Let's have
the horizontal line of sight to a point of interest above the horizontal.
Yes. Now go ahead. What do you have to say?
Was that? Well, no, I'm just confused why that was so difficult.
It's not a question of it being confusing or not. We're going to move forward. We're going to take that definition. Let's move forward with the conversation. You're getting into the meta, and it's uninteresting. Okay, let's move on.
No, I just wanted the definition for an angle of elevation,
and he gave it to you.
Simple. Okay. That simple question and the simple definition was not met. I'm sorry.
Let's move forward. What's your problem with the elevation above horizontal? That's a very simple definition we can both work with.
Yeah, how many times did it take for him to actually say that?
It doesn't matter. Do you want to have a discussion, or do you want to go hang out in the audience?
Who are you? You're not MCToon.
It doesn't matter who I am.
He's moderating.
Just a little help there?
He's moderating.
You're stuck in them. Yeah, you're stuck in the.
He's helping you, MCToon. I got it.
Quiet. Okay. Just move forward with the conversation, or you can hang out in the audience. Simple as that.
Yeah, sorry, MCToon, you mentioned earlier, I don't remember the exact angle measurements. I believe you said one was from Minnesota.
Yeah.
One was from South Florida, and one was possibly from Puerto Rico.
Yes.
Could you go over that again, please?
Yep. So the measurement to Polaris from Minnesota, I'm at 45 degrees north, and the angle to Polaris was 45 degrees. The location it was Pensacola, Florida, so not south, was 30.3 degrees latitude, and the angular elevation was 30.3 degrees. And then in Puerto Rico is 18.5 degrees latitude, and the angle to Polaris was 18.5 degrees.
Right. So, in other words, if you take an elevation angle to Polaris at 18 degrees, in other words, you go outside, it's dark out.
Yep.
You look at Polaris. I don't need you agreeing with me. This is my turn to talk. You go outside in Puerto Rico. You see Polaris at 18 degrees. You take your elevation angle to Polaris, and Polaris is at 18 degrees. That means you're at what? If, in case you didn't understand my question, if Polaris is at 18 degrees, what does that mean?
You didn't want me to talk, so you just keep going.
It means you're at 18 degrees north latitude, correct or incorrect?
You just do your presentation. I won't interrupt. Go ahead.
I don't have a presentation. I just asked you a question, you donkey.
Donkey is the name of my dog.
Well, I feel bad for your dog.
It's a pretty nice
Although
dog.
my dog's name is Fat Boy, so what can I say?
Yeah.
If you take an elevation angle to Polaris at 18 degrees, what does that mean?
I don't know. You go ahead.
If Polaris is at 18, it's a very simple question. If Polaris is 18 degrees above the horizon, where does that place you, MCToon?
I was in Puerto Rico.
Would that place you on 34 degrees north latitude?
What?
If Polaris is at 18 degrees,
yeah,
would that place you at 34 degrees north latitude?
No. Why would you think that?
Would that place you at 44 degrees north latitude?
Why would you think that?
Would it place you at 15 degrees north latitude if Polaris is 18 degrees?
No. This is amazing stuff here.
Would it place you at 17 degrees north latitude?
Keep going.
No, I just asked you a question. If Polaris is at 18 degrees, would that put you at 17 degrees north latitude? Yes or no?
Do you not know the answer to these? Are you really that bad at geometry?
You haven't answered the question yet.
No, I'm not. Go ahead. Give your presentation. Get to your point.
Why do I don't have a presentation? I'm simply just asking you a question.
Get to your point. It sounds like you're waffling because you can't explain it.
If Polaris is at 18 degrees north latitude, where does that place you? Well, actually, I just gave the answer. If Polaris is 18 degrees in the sky, what latitude does that place you on?
18 north, yeah.
Welcome to Flat Earth, MCToon.
I missed the part where you presented the geometry. All you did was you begged the question.
I presented the geometry by taking an angle of elevation to a point of interest above my horizontal. What are you talking about?
And so how far is that location from the North Pole?
Oh, let's you know what? I'm glad you asked that question. What's 18 degrees minus 90?
Do you need me to do the arithmetic for you? Is that what you're asking?
The reason that he's saying these things, Tom Zig, is because the topic is provided.
I don't need your help. Hold on, moderator. I don't need you to white knight for MCToon.
He's
what is 18 minus 90?
What
is 18 minus 90?
like there's a calculator for free on phones. It's already installed on your phone. If you need that, 18 minus 90 is negative 72. All right.
You're on mute on your end, buddy. So unmute when you want to continue with your presentation.
Alyssum says, just got here. Did I miss the flat earth measurements? No, you missed nothing. My
bad. I meant to say 90 minus 18.
Okay. Positive 72.
72.
Yeah.
Right. 72.
Okay.
Times what?
You tell me. What do you're trying to figure out the distance between
Neptune.
Where I was and
72 times what equals what? Come on now.
72 times 1 equals 72. 72 times a billion equals 72 billion.
Oh, Lord.
Do you want me to do the arithmetic for you? Fine. I was at 18.5.
No.
Hold on. 18.5 degrees. Right? Not 18. Right? So now you want my, that was 71 and a half.
You guys get your popcorn ready. Get your popcorn
So
ready, everybody.
111.1.
So you're 18 degrees north latitude.
Yeah. So it's 7,000.
Hey,
7,000
minus 18 equals 72 times what to give you what? Come on.
Okay, I was giving it to you when you so politely interrupted me. 7,944 kilometers to the North Pole from Puerto Rico. Okay, now what?
No, nothing. Welcome to Flat Earth. I rest my case.
But you didn't actually link together the geometry and flat Earth. All you did was like not be able to do the arithmetic, and then at the end you beg the question. So how did this provide evidence for flat Earth?
My horizontal. All we did was take an elevation angle to a point of interest to go to my horizontal, which just happens to be Polaris, which is how we derive our latitudes. My bad.
So you're begging the question here by just jumping to welcome to flat Earth, because you didn't actually provide any evidence for flat Earth at this point. So let me do this here. 7,944 kilometers is the distance across the surface of flat Earth that you're asserting. And we have an angle of 18.5 degrees, giving us, so here, I'll put in the solution to this triangle here. I'm sure you've gone through it yourself already. So here we have the elevation of Polaris. When we take this math that you're talking about, we get an elevation of Polaris of 2,658 kilometers. So so when you say welcome to flat Earth, are you saying, yep, because
that's
the triangle,
that's the horizontal zenith distance.
because the triangle that you're talking about now requires that Polaris be 2,658 kilometers high?
That's not the elevation to Polaris, that's the horizontal zenith distance, my friend.
The horizontal zenith distance. So a zenith is an angle. So you can't have a horizontal angle distance. I don't know what you're talking about there. So you're mixing units here. You've mixed in degrees and linear units together. So no.
Go ahead, Toon, let him respond.
Yeah, okay.
Go ahead, Tom Zig. Let's see what you have to say.
What was the let's see, you were doing it in kilometers, which I was doing it in miles, so it threw me off. What was the kilometer distance again?
The distance in kilometers is 7,944. So we're given that. If I don't know. I know you're on a phone, so it might be difficult for you to look at the diagram that I posted.
I have it on my screen share too.
Oh, there you go. Yeah. So if you can see that on your phone on Jesse's screen share. So I solved the triangle.
So 4,000, right. You solved the what now?
I solved the triangle. So the triangle there in that diagram.
What triangle?
So
hold on. You just solved the triangle. What kind of triangle did you just solve for?
So the triangle is for where I was in Puerto Rico, the line across the surface of flat Earth, the claimed flat Earth from Puerto Rico to the North Pole is 7,944 kilometers, right? And then I measured
4,320 nautical miles, correct?
I can't. I'm sorry, I can't do the nautical miles computation in my head that quick.
4,320 nautical miles. Yes or no?
Yeah, I'll do it nautical miles for you too. Fine, that's fine.
Let him go through it, Tom Zig. He's going to go through it, and then you can say, no, it's this, right? Let's have I don't like muting you. Just have a cordial discussion, have it back and forth. I don't mind a little bit, but like, let's be reasonable.
All right, so 4,290 nautical miles. Yep, that's fine. Is that what you said? I get that. All right, so I'll give you the diagram in nautical miles instead of kilometers there. So there you go. So now the height of Polaris by solving this triangle is 1,435 nautical miles. Is that correct?
Why do you keep saying the height? We haven't established what the height of Polaris is. What are you talking about?
Well, but that's what we're measuring here, because we know the distance across the surface of the Earth is.
So we're measuring the height of a star, really?
Yeah, that's what you get from this. So we have the distance between.
No, it's not.
Of course you do. This is the geometry. This is what happens when you do the geometry. You actually apply the claims.
Oh, I'm sorry. We're talking about celestial navigation, sir. We're not talking about the height to a celestial.
We're not actually talking about celestial navigation. The topic is when people say Earth measured flat and then describe the elevation angles to Polaris. That's not celestial navigation. I mean, it's adjacent to it.
Your location, 18 degrees north latitude, you just measured the horizontal distance to that as hold on. I just lost my number. What did I say? It was 4,380 miles?
4,290 nautical miles.
4,290. Okay, so let's see. 18 degrees. So
it's 18 and a half degrees.
72 times.
You don't know how to do decimals?
60 nautical miles equals 4,300. Well, I wasn't using decimals. I use 18 degrees, just a round, nice, easy round number.
That's fine. You can round off to round. That's fine. Go ahead.
Yeah. 4,320 miles to the ground position of Polaris.
All right. Okay.
No, it's not all right.
Now what?
It's not all right for you at all. That's 4,320 miles of a horizontal plane that was just measured.
No, you're begging the question though. So the reason why you're begging
how so?
Hold on a second. Whoa. Okay, go ahead, Tim.
So the begging of the question here.
How is he begging the question?
Yeah, the begging of the question here is that you haven't actually established the flatness. You've just gone to asserting the flatness. You haven't shown how this geometry works. And that's what I'm doing here is I'm taking the measurements from multiple locations and then applying the geometry that's claimed. And for some reason, you're very uncomfortable when I actually solve a triangle here. I don't know why you'd have a problem with that, because this angle that we have and the side that we have, the side being the distance from Puerto Rico to the North Pole, and the angle that we have, that'd be the 90 degrees that we have at the GP of Polaris, right? We have angle, side, angle. We can solve that triangle when you have angle, side, angle. And that's what I did. And so that requires, the geometry of flat Earth mandatorily requires, this is not optional. You don't get to say no. This is just the geometry of reality then, according to you. The elevation now of Polaris, linear elevation must be 1,400 some nautical miles above the flat Earth.
Okay, I'm glad you said that. If I'm 45,000 feet above the observer that just took the elevation angle with a mariner sextant, will my elevation angle be with the bubble sextant 45,000 feet above the observer with the mariner sextant?
Going to be a little bit less than 18.5 degrees.
No, it would be 18 degrees. If Polaris is 18 degrees 1 foot above sea level, Polaris will be 18 degrees 40,000 feet above sea level.
In fact, that's not the
height
case.
Of what now?
That is not the case, actually.
Okay, citation.
Well, I'm gonna have to go with you. Your first assertion. You're the one that first asserted it. So
you said that if I take an elevation angle 1 foot above sea level to Polaris at 18 degrees, if I was to be 100,000 feet above that same exact location and take another elevation angle, it wouldn't be 18 degrees. Really?
Prove it.
Okay, so provide a citation.
No, you're the one making this claim. Prove it.
You're the one that says it's going to be different.
In response to you saying that's not going to be different, right? So you're the one that introduced this claim, not me.
Yeah, your elevation angle to celestials doesn't change regardless of height above sea level.
Citation needed.
Citation.
So you think it will be different?
Citation needed. I do not have the burden of evidence here. You do.
You're saying it's going to be different.
You're saying it's going to be the same.
How is it going to be different?
You have the burden of proof. I'll post
Absolutely.
Here you go. Here is the burden.
Absolutely.
The burden of proof fallacy there for you. There you go. Your logical fallacy is.com burden of proof. You said the burden of proof lies not with the person making the claim, that's you, but with somebody else to disprove. So you've made the claim that your elevation will not affect the elevation angle of a star. And so you have that burden of proof. All right, I'll take it that you don't have that, and that's just a baseless assertion. So, all right, so now we're still struggling here because, and you've completely, I know you painted yourself in a corner here, and you're just trying to get out of it. And so I just want to bring back a little more heat to your feet. When you did that measurement that you talked about, right? That little bit of geometry, not measurement, I did the measuring, the geometry of the 18 degrees angular elevation at 18 degrees north latitude, right? That creates a triangle, and that tells us how high Polaris must be over flat Earth. Do you not see that?
No, it doesn't. No,
it certainly does.
We don't count for the height of celestials.
It absolutely does. I mean, I'll post.
Hold on.
I'll post. Hold on. I'll post the link. I'll post the triangle that you just described once more. There you go. So there it is in the chat.
The triangle that you just agreed with.
No,
Yes.
the triangle that you just said is the geometry for flat Earth, right there. So you just said, and so. Now I'll redo it with your numbers, because you can't handle math with decimals.
A celestial object or a terrestrial object?
It's a celestial object for sure. Yep.
Celestial object.
Yep.
Right.
Go ahead.
So if I take an elevation angle to the top of a telephone pole, right? Let's say my elevation angle to the top of the telephone pole, 14 degrees. If I climb on top of a ladder, will the elevation angle to that to the top of that telephone pole change? Yes or no?
Yeah.
So if I take an elevation angle using a mariner sextant, where I'm using the horizon as my horizontal to level off my mariner sextant, and it's at 18 degrees.
Yeah.
If I was to use a bubble sextant and take the same elevation angle 15 feet above where I just took the angle with the mariner sextant, or 1,000 feet or 40,000 feet to the celestial, would it change?
So you're switching between mariner sextants and bubble sextants? Which or not? Which one are you using here?
Well, I'm using a mariner sextant, but my partner is in an airplane, and he takes the same exact elevation angle, 45,000 feet above my head, with a bubble sextant.
Okay, and
where
so
our elevation angle changed.
All right, and when you did this, what measurements did you get?
It's a hypothetical, you moron.
Oh, you didn't do it. Okay, awesome. Well, let's go back to the measurements that I actually took myself.
Okay.
I was actually on the ground in Puerto Rico. I actually measured the elevation to Polaris.
Yeah, so
for
if
real.
I'm standing on top of the World Trade Center and I take an elevation angle to Polaris, rest in peace.
When did you do this?
9/11
When did you do that?
No, I'm asking.
You never did?
If I'm standing on top of Mount Everest,
that's too bad.
And I take an
you climbed Everest? That is so cool. What was it like? Like,
here we go.
Did you need oxygen, or did you do it without?
Mount Everest on? What latitude is Mount Everest?
I don't know offhand. No. So you didn't, or you did climb Everest? I'm confused now. All right. If you're talking, it looks like you might have muted yourself.
Oh no! I totally muted myself because I was curious. So Mount Everest is 27.9882 degrees north latitude. So would everyone feel comfortable saying that Mount Everest is 28 degrees if it's 27.9882? Like, can we just call it 27, or do you want to call it 28? Let's just use round numbers. Come on.
Yeah, I mean, it's difficult for you to deal with decimals. That's fine. Do what you need. That's fine.
Okay, so if I was, let's say that I was at sea level at 28 degrees north latitude.
Okay.
What happens? Wait a second. So I'm at sea level at 28 degrees, which you can be at sea level at 28 degrees north latitude, or you could be on the very tippity top of Mount Everest at 28 degrees north latitude. Does our angle to Polaris change? Yes or no?
What was the result of your measurements when you did this, or did you have somebody else do it?
What was the result of my measurements, or did I have somebody
Were
else
there
do it?
actual measurements that you can reference, or are you just trying to avoid the actual measurements that I took?
Do we need to find a location that's 28 degrees north latitude at sea level? I'll look up some cities for you, you bitch.
No, you need to actually have somebody that measured the elevation of Polaris from Everest, and then somebody else that did actual measurements somewhere else, and then we'll compare them. And of course, we'll take into account the precision of the instruments.
Well, let's see. The very tippity top of Mount Everest with the bubble section is 28 degrees. If I was to go to the same location,
so who measured
not the
this?
same location. If I was going to another location where I'm at sea level at 28 degrees, are you saying there's no sea level at 28 degrees north latitude?
I just want to know who measured this.
Is there a location where you can be at 28 degrees north latitude and be at sea level? Yes or no?
Is there a reason why you're avoiding supporting your claims?
You said that the higher I go above sea level, my angle to Polaris will change.
You said
retarded?
You said it won't change. So I'm waiting for you to support your claim. Okay, support your claim.
Absolutely.
Go ahead. Let's see the evidence. Here, I'll post in the chat the fallacy. The fallacy that you're struggling with is called the burden of proof fallacy. That's where you're making it my responsibility instead of your responsibility for your assertion.
Right. So you're saying that at 32 degrees north latitude, there's no sea level?
I didn't say. I said nothing of the sort.
So if I'm in an airplane at 32 degrees north latitude and I was to take an elevation angle to Polaris, what would that elevation angle be?
I don't know. You tell me once you do it.
It It would be 32 degrees, my friend.
So you haven't done any of these measurements. You don't have any citations to any of these measurements. All you have is your what you think is going to be the case. None of this is actually, none of this is pertinent to the topic. And I know that you can't address the topic. And that's why you're trying to get away from the topic.
Do not change, regardless of your height above sea level.
All right, let me post the fallacy there again. That is the burden of proof fallacy. There, you've made a claim, and now you need to support your claim. And you can't support your claim by saying, well, if somebody was here and if somebody else was here. What you would need to do is you would need to say, here you go. Here is somebody at a certain elevation with a theodolite measuring to, arcsecond precision. And here's somebody at 20,000 feet at the same latitude measuring to arcsecond precision. That would be the way to do it. Right? But you don't have that. All you have is an assertion. And this is, I think we learned the other day, this was the third law of flat earth debate, third rule of flat earth debate, that you make claims and never back them up. So none of that actually matters though, because it's still just a way for you to avoid the topic of the geometry of earth measured flat claims. And so far, what you've done is you've identified a single triangle, and yep, we got a triangle on flat earth. And then you said, therefore flat, which is a begging the question fallacy. So
if Tom Zeg, if you don't have a response to this, I do have, even if it's okay with you, go ahead.
No, I have a response. Actually,
okay, go ahead.
Yeah. Why do you place in a globe Earth model, whatever, like super quotation? My fingers are about to snap off doing the air quotes. Why are the stars infinitely far away?
They're not. That was easy.
They are. That was easy. They are absolutely infinitely far away. Light years and light years and light years and light years and light years away. What are you talking about?
So that's
a finite amount.
That's not. Do big numbers confuse you?
So you're telling me if I see Polaris at 32 degrees and I climb up 1,000 feet, my angle is going to change the Polaris?
With your bubble sextant? Oh, your bubble sextant doesn't have that kind of precision. You might get
my bubble sextant my bubble sextant is absolutely parallel with eye level. Eye level is absolutely parallel with sea level. If A is parallel to B,
but it's not.
B is parallel to C, C will most certainly be parallel to A. What are you talking about?
But it's not. But I can unlike you.
Yes, it is.
I can support my claim.
No, you can't.
Yeah, just a second. Just a second.
So you're telling me if I'm at sea level, I have I'm fucking floating in the ocean with the life jacket on, and I take a 32-degree angle to Polaris, floating in the water, and then let me shut up, and then I get in an airplane and I fly 45,000 feet above that same exact location.
That's not what you said.
Polaris would be different.
But that's not what you said. Let me.
It is what I said.
Oh, okay, cool. Okay.
Hence,
awesome. All right. Well, then I will simply once again say you are going to need to support your claim with evidence.
Support my claim that elevation angles to the luminaries don't change regardless of height above sea level? Really?
Yes, 100%. You need to support your claim. This is a pretty basic part of debate where you make a claim and then you support the claim with evidence. Did you not know this? Why are you so confused that you are expected to support your claim when you make a claim? Why is that so hard? This isn't actually hard. This is just
replace Polaris with a telephone pole.
I think Max might have had a question. He postured it earlier. Go ahead, Max.
Yes, I wanted to ask Tom, say, why don't I see Polaris I live in Uruguay. The silence of concession.
Oh, you live in Uruguay, you said?
Yeah.
So you're beyond the minimum elevation angle to Polaris, which is the equator?
Yeah, yeah.
Mm-hmm.
Yeah, so you live beyond the minimum elevation angle to Polaris. Why do you not see Polaris? Is that what you're claiming?
Right, but if Polaris is about a fixed distance above the flat Earth.
Did I say it was a fixed distance? I never once claimed anything about the distance to Polaris.
Oh, so it's not a fixed distance above.
Well, let me ask you a question. What is Polaris? What is it?
A star.
What is that?
Giant ball of nuclear fusion.
Yeah, can you support that with scientific evidence? I don't think so.
We're gonna do. What we're gonna do is
Spectroscopy. But I would like to my question answered before we go down this rabbit hole of utter nonsense.
What is Polaris?
Why
How
don't
big
I
is
see
it?
Polaris?
What's it made out of? If I was to bump into Polaris, what would it feel like?
Wait a second. Hold on a second. Don't let me pause you. Listen, Tom Zig, you've been going back and forth with Toon, assuming that Polaris is a thing. Okay, we're not going to go down that rabbit hole. We're going to move forward with that Polaris is a star.
I already smoked MCToon.
Oh, you did?
No, you didn't.
Oh, that's adorable.
I did. You notice how he's being quiet. I smoked his dummy.
I'm being quiet because I'm polite, unlike you.
Right.
So if I'm at sea level, and I take an elevation angle to Polaris at 32 degrees, and I get in an airplane and fly over the exact same location, my elevation angle to Polaris is going to change? Really?
It has nothing to do with the actual topic. This is obviously just your way of trying to get out of the corner you're painting yourself in.
32 degrees at sea level, my feet are in the water.
Wait a second.
In fact, I'll walk forward.
All right. I'm going to do it for you. Wait a second. Listen, Max had a question for you. It was very specific, and you diverted. You went to, oh, well, how do we know this?
That was
how
a
do
runaway.
we know that? Polaris could be invisible, blah, blah, blah. What I want you to do is Max, I'd like for you to restate your question, and then we can move forward. I'll let Tom Zig respond after you restate it. Thank you.
I live in Uruguay. I cannot see Polaris. And I've been in Brazil, Argentina, Paraguay, Chile. You can't see Polaris from anywhere over there.
Go ahead, Tom Zig.
What's between you and Polaris? That's what I want to know.
Hold on, Jesse. Let him respond. Go ahead, Tom Zig. You have the floor.
Man, that silence is rough.
Did you walk away from the microphone, buddy?
All right. Well, while he's pondering the challenge that he's got himself, that pickle that he's put himself in, Earthly Skeptic says, on a globe we measure altitude. On flat Earth, attitude. Rossi says, Toon, ask him how he defines and finds horizontal. Oh, that's a great question. How do you find horizontal flat earthers? Tom Zig, particularly, how do you find horizontal? All right. I'm
unmuted. I'm sorry. What was that question? How do I find a horizontal or define?
How do you find horizontal? So you've got your theodolite there, or whatever instrument you want. How do you find horizontal?
Well, it depends on what instrument you're using, right?
What use whatever you want. Whatever you want.
Yeah, if you use the Mariner sextant, you establish your horizontal based off the horizon. Hence the horizon mirror.
So now, so a question then: can you use that? Can you use that in an airplane at 45,000 feet?
I'm not
30,000 feet.
Finished. If you use a bubble sextant, you establish your horizontal based off the bubble in the sextant itself.
Okay. And now, are those the same when you're in an airplane at 35,000 feet, for example?
They're parallel, absolutely.
I can prove you wrong.
Go on.
A friend of mine, too,
All right, in
I
the
know
chat.
that Buck has
No, he said he was going to prove me wrong,
Yeah.
so go on,
All right.
dude.
That's fine.
All right, here we go.
Afterwards, a friend of mine, Buck, might have a word to say about theodolites. He's had a lot of discussion lately. Go ahead.
All right, so I put two pictures in two measurements in the chat there. The second one is from 11,000 meters, around 35,000 feet, and so this is the theodolite app on a phone, which is accurate to 1/10 of a degree. And the horizon at this elevation is depressed by 3.3 degrees. So if you were to use a Mariner sextant and compare it to a bubble sextant, you would have a difference of 3.3 degrees in their measurements.
Only there was some way of correcting that.
If only there were tables for that. Furthermore, here's another one. Science is good if it's repeatable. Here's a second one here from 34,000 feet, where the angle to the horizon is 3.2 degrees down. I got another one here, one that I took myself at, let me see here. Is this the one? Yep. Also with a theodolite app. It's a different screen. You can change with the theodolite app what it takes pictures of. So this is at, let me see this was on the way to Santiago from Miami. I was at it's an elevation angle of negative 3.4 degrees, and I need to use it was about 38,000 feet elevation, if I remember correctly. So there you go. There's a couple examples for you.
Oh, sorry. I'm unmuted.
Okay.
In celestial navigation, are stars treated at an infinite distance or not?
So I'm sorry, you just jumped to a totally different topic here. So you were talking about.
You're talking about.
Oh, you weren't participating in the conversation.
Oh no, I'm just. Well, I mean, this is the conversation.
Hold on. I'm gonna restate what you stated. You made the assertion that a bubble sextant and a Mariner's sextant at a high elevation, for example, 35,000 feet, would give you the same measurement, and I just proved that they would be off at 35,000 feet by about 3.5 degrees.
Wait, if I took a Mariner sextant in an airplane and then took a measurement at 35,000 feet, is that what you're saying?
Yeah, because you said they'd be the same, and I proved that you were wrong.
No, idiot. If I took a fucking Mariner sextant and took it from the brig of a ship, not taking the Mariner sextant into an airplane, are you retarded?
Why not?
Excuse me?
Why not?
Why would I not take a Mariner sextant into the brig of into an airplane?
Well, see, I asked you, and you said with 100% confidence that a Mariner sextant and a bubble sextant would give the same measurement. I mean, I streamed it out to my live YouTube. Can anybody confirm whether or not I'm remembering that statement correctly? Icy Spin?
If I'm on a
hold on. We're gonna verify your claim here before you move on. Icy Spin. Can you please clarify if I'm remembering this correctly? Did he say that a bubble sextant and a Mariner sextant would give the same measurement at a high elevation in an airplane?
He did.
I would love to confirm that, but unfortunately, first of all, I'm playing the.
Is this what we're doing? Really?
No, listen. Wait a second. I'm playing the middle, so I'm not going to take a position on it. But I actually didn't hear what the play was. But go ahead.
Jesse, do you recall? Hold on.
Wait a second.
Just a second.
Feet.
Just a second. Jesse, do you recall?
Okay.
I'm sorry, I was tuned out.
Oh, all right. Buck. Buck Sodbuster, were you?
Sundito in the chat says that Toon is correct.
Okay, got it.
This is the part where Tom Zig that you support your claim. Toon has made an assertion that you said both of them are the same. Go ahead.
Yeah, they are the same. If I'm on the Mayflower, and granted, when you take a elevation angle from a ship, you're taking it roughly from the same spot each and every time. Ask Protothad, he went over this with me exclusively.
Roughly from the same spot.
Yeah. If the spot that you're going to take your elevation angle is 75 feet above, the water, you're going to want to stay in that because they do all the dip correction at port.
They don't do it at port. If you're at sea and you want to know your location, you don't get to wait till you're at port to do the dip correction. You do it when you sit down at your desk.
Done at port, you moron.
No, it's not. It's done when you're doing your computation.
Yes, it is. If I'm going to stand on X part of the ship, they measure that at port while the ship's tied up, and you know the exact height because the ship's fucking docked and it's tied up with ropes. And the ship's not moving, and you realize how high you are above sea level. You fucking idiot.
Wow. You really are desperate here. Wow.
Wow, I'm really desperate here. Wow.
So here we are. We're out at sea. We're unknown miles away, and we don't know our location at all. And we're gonna measure angles to stars. And then we measure them. We write them down, and then we go to the desk and we say, well, we can't do anything until we get to port.
No, you idiot. The part that you take the part of the ship that you take your elevation angle from was already recorded at port. You realize, hey, if I'm standing up on the bridge, I'm X amount of feet above the surface of the water. What the fuck are you talking about?
So the dip correction is actually a table that you look up. You say, all right, I know that I'm on the bridge here and I'm 75 feet high, as you said. And I'm going to look up in my table here that's in the Nautical Almanac. What is the dip correction for 75 feet? And then you apply that to your computation.
Yeah.
Yes, you don't wait till you're at port. You do it when you want to find out your location. You're like, I'm out here at sea. We better do it right now.
Before you even leave to go on a voyage. What are you talking about?
You can't do the dip correction before you leave on your voyage because you didn't measure the angles of the stars yet.
You do, because when your ship is tied to the dock and your ship's not rocking, and you go, hey, this is the best part of the ship to do celestial nav from, so we're going to do it from here.
Okay, then what? What about it? You're going to do it from the same spot. Awesome.
Height from sea level.
Your linear height from sea level? Measuring your linear height from sea level is not the same thing as applying the dip correction. Oh my goodness.
Do you think you're doing celestial navigation when you're in the fucking middle of a storm and the ship's like flowing and you're going up on big waves? No, you moron.
Oh my gosh. All right. So it's so funny how you cannot address the topic. I love it.
Cope. You're literally just coping, bro.
I'm laughing at how bad you're doing. But you go take a victory lap. That'll be funny.
You're making fun
Can I ask Tom Zig a question?
I don't think so. I think we need to stay one-on-one. But I don't know. We've been going for 3 hours. I mean, we've only had one actual Flatty in here, so I do appreciate it, Tom Zig, because Dimmock he's only a random derp generator.
If this part's exhausted, Jen, if you feel like it is, I did tell Buck he could come up.
Dude, you're literally denying the fact that if you're 1 foot above sea level, or 4,000 feet above sea level, or 45,000 feet above sea level, you think your elevation angle to a celestial is going to change.
I don't know. I'm just asking. I'm just waiting for you to support your evidence.
Literally wrong.
But I don't know how whichever way it goes is going to make any difference at all.
You don't do celestial navigation in bad weather, you fucking donkey.
I never claimed you did. I don't know why you'd think that.
You just said bad weather.
No, I didn't.
Oh, I misheard you then.
Yeah, it clearly did.
You don't do celestial navigation in bad weather, you fucking idiot.
I never claimed you did. Are you on loop?
Yeah.
What the
You know
hell?
what's funny?
Insults.
What the hell
You know
is
what's
wrong
funny?
with? Are you on loop? Are you literally on loop?
Let's put it like this. If you're, let's say that the seas are perfectly calm, right? Perfectly calm seas. You know, the water's like a sheet of glass. And we've all, anyone that's ever been in a boat has experienced this going out in the ocean. I have. The sea is perfectly flat. Your boat's not rocking at all. But guess what? The fog is going from the apparent horizon all the way to the front of your boat. How would you do celestial navigation then? Because the thing is, it's super foggy.
Can you still see the stars?
Shut your fucking mouth. Shut up. I'm not finished.
Can you still see the stars?
Everything is foggy, but then you look up and you see stars. Yeah.
Oh, I can do
You
that.
can see stars.
I can do that.
But you can't. But you can't
Do
see.
not swear on my show.
So I can do that. Yeah, I would use.
Yeah.
I would use.
But you can't see 10 feet in front of your position.
Yeah, you can still do that.
And you're on an 80-foot brig. But the thing is, you can't see the horizon. You can't see anything. You can look up and see stars. What do you use?
Well, if I had a bubble sextant, that helped. But you typically have a mariner sextant. So then you ask me a question, I'm going to answer. You ask me a question, I'm going to answer.
Wait a second. Wait a second, Tom.
You need look, little boy. You're going to have a little impulse control. You rude little piece of garbage. You're going to have some impulse control. Tim. You ask me a question, then you shut your face hole. Right? So I would say you could use the old trick of pouring a plate of molasses. You could use other things, but molasses is good because it doesn't slosh around very quickly. And then you measure your sextant. You eye the star in the molasses and the star in the sky, and then you cut that angle in half.
Cut the angle in half.
Yep, that's an old trick.
Words, you would use a mercury table and then cut your angle of elevation in half.
I'd use molasses, not mercury.
If I take an elevation, well, whatever. It's actually a mercury table, not molasses, you moron.
Well, if you put mercury on a plate on a ship that's rocking around, you're gonna have mercury all over the floor. That's a bad idea. Molasses is much better way to do it. Yeah. So I'm much smarter than you, buddy. I just I'm significantly smarter than you.
So mercury tables don't exist.
I'm just you asked me how I would do it. I would use molasses.
Yeah. Let's hold on for a sec. All right, Tom Zig, try to bring the energy down a level. Okay, you've got a lot of insults. Let's just go back and forth. I know you're passionate at this point in the argument, all right? But let's try to be reasonable. Let's try to listen to each other's arguments. Try to move forward from this, all right? I don't want it to be an ad hom attack, as you guys might say. So let's just think about what each other is saying and move forward. Okay, go ahead, Tom Zig.
Yeah, so mercury tables don't exist. It's a lie that I just made up, right?
Yum.
What I want you to do is to address what he was talking. He mentioned molasses as a good a liquid that doesn't slosh around, right?
No, MCToon said mercury tables don't exist because you'll get mercury all over the floor of the deck.
No, that's not what I said.
Why don't you address?
Not what I said.
All right.
Yeah.
Tom Zig, hold on for a second. I want Toon to restate what his claim is. Tom Zig, I want you to respond to what
mercury tables aren't real. Mercury tables can't hurt.
Okay. All right. He's got no control.
Yeah, self-control problem. Yeah. So he asked me how I would do it, and I answered how I would do it by saying I'd pour it in molasses. And then he said, Good. He said it's a mercury table, you moron. I said, well, I would use molasses because if you pour mercury on a plate, is what I said, If you pour mercury on a plate on a ship that's rocking, you'll have mercury all over the place. If you do it with molasses, it'll be on the plate still because it doesn't slosh around. But he didn't want to hear that. He wanted to hear something else. And he's so desperate to stay away from the topic that he had to fixate on whether or not mercury tables exist. Of course they exist. I didn't say they didn't exist, but he asked me what I'd use, and I told him what I'd use. Yeah. Not a mercury table, because I don't have one, but I can go get molasses.
One side note, too, he arrived on server mute. I don't know if anyone else noticed that, but I had to unserver mute him from the get-go. So it sounds like he likes to go around spouting off and getting server muted, but
yeah.
Neither here nor there.
So he came into a Flat Earth Discord server pre-muted from the Flat Earth
pre-muted, yeah.
Flat Earthers before somehow. But
and
in the
I think
end,
Riggs would say that I think Riggs would say that this isn't a Flat Earth server. He's in the audience now. He can step up and say what he wants if he wants, obviously.
Oh yeah, if I'm not right there, Riggs,
I think he would say that it's it's an alternative idea server or something to that effect. You can clarify that if you want, Riggs. But yeah, I think Toon's right when he says, generally speaking, Flat Earth comes up at some point during the discussion, among other things. But yeah.
I put on my screen share an article about using molasses for sextants.
Oh, very nice.
Oh, cool.
It says molasses, the eatable artificial horizon.
Yeah, and
can you?
The nice thing about it, of course, is that on old timey ships, that was something that potentially would have been around, where a mercury would be in short supply.
Not to mention that healthy.
Can you drop that link? I'll share it with the YouTube audience. Go ahead, Buck.
I had a question for you, Toon.
Yeah.
Like, what's the strat? Like, obviously he believes that celestial objects have this magic property that their elevation angle doesn't change as you change your observation height, because he obviously doesn't understand the precision of the measuring tool and how far away the object is. So why not put him out of his, like, why not expose that misunderstanding?
So he obviously can't do geometry, right? He really struggled to do even basic stuff. He couldn't even do decimals, right? He can't handle decimals. So he's never, he probably barely scraped through high school math and hasn't done it since. So, any of this geometry that we're talking about, he's not going to understand. He only has vague concepts of it. So he's looking at, I don't exactly know the line he was going down. I've heard it before. I don't remember. Why is that? What would it establish whether or not the elevation angle to a star changes or doesn't change with a varying elevation?
I can tell you why they believe that, where they go with that.
Okay.
It's their explanation for how the relationship between the elevation angle and to a star and the distance to the GP of the star can be linear on a flat surface. It's their get out of jail card free, because they believe that the height, that the star has some magic property, and their justification for the star having some magic property is that when you observe from a higher point the elevation angle doesn't change.
I see. Yeah.
And they think that's the magic, and they don't understand.
So they've not done the geometry. Yeah. So all right. So if I could say, like, if the star is 5,000 kilometers high above flat Earth, and then you raise your elevation, then above flat Earth, then it doesn't change because of magic, right? Well, except that
literally magic.
Yeah, literal magic. No reason.
Who knows? Magic.
Yeah, no known reason why. It just does because it just does. But the problem, of course, is they're going from 0 kilometers high to 11 kilometers high and saying, well, if it was 5,000 kilometers high, there should be a difference in that angle. And okay, there should be. And do you have an instrument capable of measuring that difference? And of course, you don't. A bubble sextant nor a mariner's sextant has the resolution to measure that difference. It's going to be very slight. But since they can't do math and they can't handle the geometry, they couldn't go and actually do the work and do, put together the triangle that is the one for when they're on the ground and the one when you're at 11 kilometers up. They can't do that. It's beyond their capability to actually compute to solve those triangles.
I mean, he presented that example of measuring the elevation angle to a light pole from the ground and then on a ladder. And if suggesting to him, what if the light pole was 1,000 feet? Would you still see an elevation angle change? Yeah, you'd see a little. What if it was 10,000 feet? What if it was 100,000 feet?
Well, yeah. So if the light pole is 30 feet high and you're on a ladder that's 10 feet high, well, that's a significant portion of the height of the light pole that you just increased yourself of. But like you said, if it's 1,000 feet high and you raised up 10 feet, that's not a significant portion of the height of the light pole. And if it's 10,000, 100,000, a million feet high, well, your 10 feet is making very slight difference in the actual percentage of how much you're climbing up that height, right?
So here's the big question. Do you think that could have been explained to Tom Zing, whatever his name is, Tom whatever, and he would have said, oh, that makes sense? Or would he just deny it?
He'd just deny it. So, and here he goes. I love it when flat earthers go and they asked AI, right? Is AI a credible citation? Never. It is never a credible citation, everybody. If you're a lawyer and you ask AI for case history, you'll lose your license. If you're doing science, and you ask AI a question and then you just publish what the AI answered, it won't go well for you. So what does he do? He goes to AI and the answer, if I am at 0 degrees sea level and whatever, he probably was asking the question. And the answer is no, the elevation angle to Polaris will not change significantly. Uh-oh.
Yeah.
Significantly.
First law of Flair, right?
Let's read the rest of this here. The elevation angle of Polaris is an approximation of your geographic latitude, which remains the same when you gain altitude directly above the same location. Polaris is located approximately 433 light years away. First law of Flair. The change in altitude of 40,000 feet is negligible compared to the vast distance to the star. It doesn't say it's 0. It said it's negligible. So that contradicts his position. Man.
Is that first law of Flair or second?
That is the first law of Flair. Yeah. The second is Flair challenges are fake. So DMOC went for that one earlier.
1 second, guys. So Taylor's got her hand up. I don't know where we're at in the night of your stream, Toon, but looks like she might want to have a chat if you're game for it.
Yeah, I think that'd be good. But let's just remember the topic is the claims from flat earthers for many years now saying Earth is measured flat, and then I'm just asking for the application of geometry to the measurements. So I provided some of the measurements I took, and maybe there's some other measurements that people have taken to support the positive claim of Earth measured flat. So Taylor, I'd love to hear your take on that.
Welcome to the stage, Taylor. I think that you might have heard everything Toon said, but if you didn't, you can ask for clarification. You have the floor. Go ahead.
So you said you took some measurements, MCToon?
Yes.
Okay, what were those like?
At 45 degrees north latitude in the Minneapolis area, I measured the elevation of Polaris to be 45 degrees. And in Florida at 30.3 degrees north latitude, I measured the angle to elevation angle to Polaris of 30.3. And then when I was in Puerto Rico at 18.5 degrees north latitude, I measured the angle to be 18.5 degrees. And so what I did is I plotted them out using GeoGebra.
It's on my screen share.
Yes, thank you. And so what has been said multiple times, specifically by Nathan Oakley, is that you get a triangle then, because you have from your location to the GP of the star, which is at the North Pole, and then you have a 90 degree. Nathan Oakley literally has said, then you have a 90 degree, right? So you have angle side angle, and so we can solve that triangle, which will then give us the elevation of Polaris for flat Earth, according to the claims that Nathan Oakley and other flat earthers have said, at least. Now, if I'm getting the geometry wrong or something, then correct me. But there you go.
Okay. This was done at different times of the like night, year. I was just kind of curious. Usually there's like a materials and methods section to go with it. You could read over what they did, but I see the chart.
Yeah.
I was just looking. What's your X and Y axis? I see
so
they don't have units on there.
Yeah, the X axis.
G and H.
It's all kilometers. So the X axis is the surface, the claimed surface of flat Earth, and the Y axis is the GP line of Polaris.
That doesn't really clear it up to me.
Well, so
what's the G and the H on the Y axis?
So, for example, the one that's between 3,000 and 4,000 on the x-axis, and 1,000 and 2,000 on the y-axis. What does that dot signify?
So that signifies the height of Polaris by solving the triangle at that particular location on the surface of the Earth. The G and H, I don't know what they're there for. Yeah.
I'm so confused.
Yeah, just ignore the G and
We
H.
need a caption.
Yeah, so the units are kilometers, both vertical and horizontal.
Oh, so the X and the Y axis are all kilometers?
Yep.
So you move this many, like...
So the one there at 5,000, where it intersects the x-axis at 5,000, that's Minneapolis. So at Minneapolis is 5,000 miles from the North Pole. And then the one that's just a little bit shy of 7,000.
Why is there a line? Why isn't there just a point at the elevation you saw Polaris?
So that line, that diagonal line, that is the line from where I was to where Polaris is. That's the line of sight.
And then the elevation angle of Polaris?
The elevation angle isn't labeled on there, but at 5,000, the one on the left side there, that's the angle is 45 degrees. The middle one
is that represented on the chart?
The
Where's
slope,
the 45 degrees.
The slope of the line.
Oh.
I'm colorblind, so I can't identify the color. So I'll just say that the line that's
so it's the green line.
That
the
crosses,
green line is at 5,000 on the x-axis and 5,000 on the y-axis. Is that right, Toon?
Yep, that's
the furthermost line on the x-axis to the left.
So that is Minneapolis, and the slope of the line there represents a 45-degree angle. So it intersects the y-axis at 5,000. So measuring the elevation angle and then solving the triangle using flat Earth requires that Polaris be 5,000 miles linear elevation above the North Pole when measured from Minneapolis. And then the middle one there, I think that's blue. The blue line, is that correct?
Yes, blue.
Okay, the blue line is in Pensacola, Florida. And so that angle there is 30.3 degrees. And it intersects the y-axis, so the elevation of Polaris when measured from Pensacola is just under 4,000 kilometers. And then in Puerto Rico there, the farthest to the right there, where it's intersects the y-axis about 8,000, then the elevation of Polaris above the flat Earth is 2,800 kilometers. And And you'll get these measurements every day from all of those locations. If you only want to measure to 2 sig fig, then you're going to get that, without any problem every day.
Mm-hmm. So did you do celestial refraction? I'm just wondering.
I did not take any refraction into account. But we know that
aren't going to be happy about
that refraction will modify it at those elevations by a rather small amount. But if you want, we could look up, what is the adjustment of refraction when you're measuring something that's 18.5 degrees elevation, right? So I think people could probably just quickly look that up in a nautical almanac. It's not going to be much, but I'll try to pull it up here quick myself.
I'm sure you've heard about the celestial theodolite. Well, they tore them to pieces for the not counting for the refraction.
Yeah, and so the celestial theodolite was measuring to a much finer precision. I listed 3 sig fig. And the celestial theodolite was measuring to better precision than that.
And right? At the horizon.
It's true, yeah. Let's see here. I think it's in my Evernote. All right, so so this is just while I'm getting the refraction numbers here. How does this work with flat Earth?
I wouldn't know. I mean, I do believe in the Bible. It talks about the mysteries, the heavenly lights. I think they're designated mysteries. That's just me personally. I don't study celestial. I study more terrestrial observations and refraction and stuff like that. So I'm not an expert, but there's probably better flat earthers you could talk to about this. I'm not sure.
May I
just didn't understand what the chart was at all.
Taylor, I know that you went to the salt flats and there were, I think you made measurements at the salt flats and you measured the lapse rate. If I remember correctly, we had a short conversation about you using a drone. Which I thought was very creative. If I'm correct about that, but was there anything that became of your measurements that might be useful in a discussion like this?
Not for celestial observations.
Can you tell me more about what you were doing with your measurements and what you hope to show, or did you disprove?
Yeah, I just hope to. Yeah, I was just like hoping to use do a surveying experiment, 1 mile distance, and actually try to like account for atmospheric conditions. So I read a bunch of terrestrial refraction papers and how like the most important thing to see the refractive index is to get the vertical temperature gradient. So I like got that, tried to calculate and incorporate it along with pressure and humidity, which was pretty negligible. Just to like try to incorporate those into some survey measurements. And I've sent the data. If you want me to drop it again, I can. But shout out to Jesse for helping me with some of the math. He's a amazing mathematician. So, and he had a spreadsheet.
Yeah, I think that would. Okay, I'm sure Toon would like to see that.
Yeah, and MCToon, did you look at the terrestrial refraction papers I sent you?
Some of them are already on my website, and I've read them already.
Yeah.
Yeah.
These are newer, kind of like because they kind of come against the standard refraction idea.
Yeah, I don't like standard refraction. That's useful if you don't know and if you have a well-controlled condition. So if it's overcast, that helps. And if where you're not skimming the surface of the earth or the ground, then that helps. And so that's where the standard refraction is used if you don't have better information. But
yeah, well, there are may be better places to do it than others, but if you just compensate for it, then that's what you should really be doing. Because sometimes surveyors can't help but to be on the ground. Most surveying is going to be like on the ground, shorter distances. And they say to be accurate to get like to get the temperature gradient incorporated. And that's what surveyors should be doing if they want like the most accurate measurement. And I implore Globers here who do survey measurements to do the same. So yeah, I've cited the Journal of Surveying and Engineering recommending this practice as best practice because the standard refraction is so like unapplicable for the lower layers and regions of the atmosphere where we all reside. So like, they'll get like upper layers of the troposphere and maybe even like start analyzing some of the layers above it, but that's not really applicable for the troposphere and the lower layers which we reside on a mountain, off a mountain, wherever. They're just talking about how they're not applicable because they're done in such large increments over like at least 100 meters, and that temperature gradient is not going to reflect the temperature gradient near the ground, especially not during the daytime when solar radiation is going to be heating up that ground below you, wherever you may be.
Okay. Well,
so I cited those. They're good. Just check them out if you get a chance. Anyway, in terms of this thing, I would like to see it with celestial refraction incorporated, but if that's too hard, it's cool.
No, I'm getting the table for the Nautical Almanac. I didn't have it in the folder I thought it was in.
That's cool. Don't worry about it.
But it's gonna just a second. It's gonna modify it by like 1/10 of a degree at the most, and so that's outside the precision of the measurement anyway. So it's not gonna change any of it. It's not gonna make a difference for flat Earth in this instance because it's too high in the angle. So anyway, go ahead.
Well, what was the lowest angle you observed?
18.5.
Okay, it's getting pretty low. All right, yeah. I mean, it still would be helpful though, because you know how hard they get on flat earthers for not incorporating refraction. So
yeah, but the reason why is because flat earthers do it where refraction is maximized across water, late in the day when the sun's been beating on the water all day, and you've got all sorts of conditions going on, and they're like, "Oh, look, it's a black swan!" Like that is absolutely leveraging the most refraction you could possibly use. And you're drawing on that one picture, you're going to draw a conclusion about the entire Earth. That's desperation there.
Well, yeah, and when the sun's been beating on the Earth all day, that would actually help you guys because the temperature gradient is going to make it to where things are going to appear shorter. So if anything, the black swan would happen if the water is like cooler than the air above it.
Yeah, but you don't get that. You get all sorts of effects. You get ducting and things like that, and that's what you see with their claim to black swan is there's ducting going on.
Ducting.
Yeah.
Is that when the density layer is lower or higher?
That's when the light bounces up and down between different layers.
Seems like it'd bleed all over the place.
Exactly. That's the problem.
Like, how would you get an image at all? I don't know.
Yeah, it's a mangled image.
Could you be in a zone or a region where you would miss, like if it's ducting like radio waves, could you be in a region where you totally have a black zone, you don't see it, and you back up and you see it again?
No, you'll still see light. You're just going to see light that's from different areas, right? It's not coherent. So that's where you'll get fuzzing and blurring and overlapping things and stuff that you can't make out and that kind of stuff.
Would it be accurate to say, like, do you remember the poles and the famous black swan image where the poles were like kind of really just kind of shaking and like they were just jagged and they were clearly.
You mean the crane off to the side?
Ducting? Yeah.
Yeah, that's an example there because you see all sorts of. I mean, I can get that.
Hey, Toon?
Yeah, grab that image. That would be helpful.
Just back of the napkin, it looks like at 18 degrees elevation angle, the astronomic refraction would be 0.04 degrees.
Okay, so when I said 0.1, it was too much. So all right, so to adjust my value, so I said 18.5. So then it would be 18.45.
Okay.
Right. So that's not going to make a big difference. We're going to make a triangle. The triangle's still going to be significantly different. And so when you're looking at the diagram that I did there, you're going to have just a very slight difference in that angle, probably no more than the thickness of the line that's drawn on there. And so it's not going to help flat Earth, because flat Earth still has a dramatic difference between the 5,000 kilometer elevation and the 2,600, 2,700
Can you
elevations.
show what it would look like? I know you're like projecting a flat surface in the star. You're getting the elevation of it, but like, and you're saying like, yeah, this makes the Earth curve. But what about like if you do like a curved sky? Like even if it was at the same rate of curvature.
So since we're
Would
measuring
that affect
angles,
it?
we're measuring angles to just one star. It doesn't matter
Yeah.
if the sky is curved or not, because it's just one position, one thing. So if the
Okay, I
if the
see.
sky like because some people say that the Nathan Oakley, for example, says that the sky is a flat plane, and some people say that the sky is a
gosh.
dome. It doesn't change anything.
Yeah, I don't.
Because Polaris is only at one spot, either in the flat plane or in the dome. It's the same spot. When you're,
Yeah, I think everybody kind of looks up at the sky is a little bit perplexed. I mean,
I don't.
the fact that everything's moving away from us, the dark energy and the
I'm not.
galaxy
I'm not really
spirals and
perplexed by it.
Well, I mean, you know that they've had to invoke like 95% unknowns to like compensate.
Nope. That
for what we're observing.
that is a hypothesis. So for they've seen in galaxies that are many light years away, which of course doesn't work with flat Earth at all, but many light years away, they've seen that it looks like they're rotating at a rate that is different than what we expect for the amount of matter that we see in that galaxy. So then that's a question. Well, what is causing that? So then there's a couple different hypotheses, and one of the main hypotheses is that there's dark matter. Now, when you said 95%, that's talking about, I think, the dark energy, not dark matter, right? And that is the hypothesis.
Well, that would be both combined.
Yeah. So the hypothesis of why things appear to be moving away from us, why there appears to be an expansion to the universe, and that hypothesis is that there is some force and energy that is causing things to be repelled from each other. And that's all it is a hypothesis, which is completely separate from things that are much better known, like what is the composition of the star Betelgeuse or Polaris or Sirius. Those are much more well understood. And then, even closer things like what about the motion of the planets around the sun? That's very well understood. We can predict centuries in advance where they're going to be. At least we can predict well enough that I knew to drive to Texas in 2024 and exactly where to put my chair in 2024 to be in the middle of the path of totality.
Mm-hmm. Yep. Well, I think even according to the Bible, there's going to be mysteries, the heavenly lights.
But a lot of those aren't mysteries. So,
Well,
but I think it's fair to say
that they're redshifting the galaxies, the fact that they form so quickly. I mean, there's just a lot of things unknown on both sides, and I think that's what the Bible says is, the case.
So I think it's always fine
That's just me.
to say there are mysteries, and science definitely confirms that. Every time we have a big understanding of some new frontier of science, there's a whole bunch of new questions that we come up with. And from a religious perspective, a theist perspective, to say, you know what, that's just the mystery of God. That's great. I think that's fine. And I think that particular position, I think, is well established throughout different scientists throughout history. there's more mysteries. Awesome. What an amazing universe.
Yeah. I'm not saying we should stop learning, but I think we should keep learning.
Yeah.
I just think that there might always be some mysteries, even with like the origin of the universe. That's the
certainly
that's created all these
certainly
stars.
not well like
Like, how did
we've
all this
totally
come to
figured
be,
it.
No,
not yet.
No.
What's
I don't
the
know.
radius? What's the radius of the globe? Yep, we got that nailed. What is the mechanism a millisecond after the Big Bang? Well, we got a okay understanding of it, but if somebody else comes along and says, you know what, I think that's all wrong, and this is what I think, and here's the evidence for it, people are gonna say, well, you've got to do a better job, but let's listen.
Are the stars the best evidence of what nails the radius of the globe? Do you think?
It's one of many.
Okay. What do you think's the best?
Well, we talked a little bit, Taylor. We've gone back and forth on Discord a couple times, and we talked about some of the measurements that you actually have on your site too, and about the way that they measured the radius of the globe by measuring the distance to the sun with radar back in the 50s. And I think that we probably came to a standstill a little bit, Taylor. I don't know if that's where you were going with it, but I just wanted to mention that.
No. Definitely wasn't going with the sun radar measurements. I think we concluded that there was so much background noise, it'd be hard to exactly know because they were getting a bunch of different signals in response. So to say which one was the bounce that we should go with, kind of subjective. But your whole point was that we can bounce it off the sun. Okay, fine. But in terms of determining the radius of the Earth by that, I don't think that was the mission or the conclusion.
No, that wasn't the goal of that. And they weren't actually, their intention wasn't measuring the distance to the sun in that. That was a byproduct of it. They were examining.
They had so many responses. Yeah, they had so many delayed signals at different time points sent back. So which one would you go with? Unless you did range gating, like they might do with the moon.
Yeah, you're still going to get in the range of 93 million miles or 150 million kilometers, right? You're not going to do range gating and find it to be 5,000 kilometers. That's the important thing, right? There's no way.
There was a few minutes of signal responses they were getting back from the sun. I wouldn't say that's the best evidence because they said it was inconclusive. They need better, It's just so much. So much noise
remember,
and delayed signals
they were not trying to measure the distance to the sun. That was a side effect, right?
Do you think that was a side of? Is that in the paper that we got the distance to the sun from this experiment?
No, it was not. That's why I said it's a side effect. They already knew the distance to the sun.
Did they? Okay, so it's not a side. Did they?
The distance to the sun was previously measured, and this I like this one because the math is very simple, right? The way to measure the distance to the sun using Mercury or the moon or Mars is pretty complex. But just bouncing radar off of something, people understand that because they know what police do when they bounce radar off cars to get distance or to get speed, right? And people use lasers in their homes to measure the distance between a wall, right? It's the same thing, right? It's photons going back and forth and measuring the time.
One equivalent.
Yeah, absolutely. So people, I'm just saying,
the data I saw from the sun was really messy.
The
point, their conclusion was we need better technology to even try to do this again.
But to do what it was that they were trying to do, which was not measure the distance to the sun, completely separate. So the reason why I like that one.
They were getting signals at different times because they were saying that it was bouncing off of different layers of the sun. That's what they were concluding.
So
that it was happening from. So which one would you go with?
Yeah. So you may have a 500,000 mile variation in it. Whoop-de-doo. You still got 93 million miles away. So
I think it was.
And like I said, the reason why I do it is because people understand round trip time of photons. They get that. That's easy to understand. There's no trig involved. There's no parallax. There's no first measure the distance to Mars involved. It's just send radar, time it to get back. That's it. It's pretty cool.
But it wasn't that simple for the sun. Maybe, arguably for the moon, I'd like to see one that's not range gated, but for the sun, it was extremely messy. I don't know why I keep saying brought that one up.
It wasn't messy in terms of figuring out the approximate distance. It was only messy.
I'd like for you to prove that.
It was so here it is. About 1,000 daily radar experiments have been made, right? That's what they said. And then let me read here. In one of the publications, it says the radar bounce took approximately 1,000 seconds. That's it. That's the precision that they provided. That's the precision they provided. In the other one, it was approximately 16 minutes. So there's two different papers. One of them took 1,000 seconds. The other took 960 seconds. Both of them were approximate.
But wait, you're acting like they got one bounce back from the sun.
You're not listening.
No, you say it took approximately 960 seconds, but they had multiple return signals over like the span of minutes, from what I remember reading.
Yeah, you should read it again. None of it matters. You're going off into things that are completely immaterial to the topic. The topic is how long did it take?
I didn't bring this up. I see expanded.
Yeah, the topic is how long did it take? Approximately 1,000 seconds. Was it sometimes 1,200 seconds? Yeah, okay, fine. Was it sometimes 950 seconds? Yeah, okay. But does that change whether or not the sun is at the distance that it is required to be for the Earth to be a globe and the solar system to be real? No, it doesn't. Does that completely
8-minute span?
Does that completely and absolutely undeniably, with zero way to get out of it, reject the absolute possibility of the Earth being flat? Yes, it does. It cannot be flat.
They were getting like 8 minutes of signaling back.
I think, to be fair, though, I think that what it does is it denies the fact that the sun is local.
Yes.
Right? Would that be fair to say?
Cannot be local. And so what they did is they transmitted for 1,000 seconds, and then they listened for 1,000 seconds. And so they read data back for 1,000 seconds or 16 minutes or whatever they read it back for.
Yeah, we had to pull up the paper. It was very inconclusive.
I can present it for you. I have no problem doing that. I have it right here, but I sent the link.
Yeah, this was your topic. So yeah, you should definitely
present it. Well, you know what? I brought it up because it was something that's on the tip of my mind that we talked about recently, and so I have no problem showing it. Give me a moment. Let
me see. I want to say something. PTSD had a really good thing. He said, there's never been a mystery to which answer was demonstrated to be God did it. And you're right. That's never been demonstrated because it's outside the purview of science. My point was just a theist could look at the mystery that is now uncovered in a new scientific, understanding and say, oh, look, there's new mysteries. And a theist could say, get comfort from there's the mysteries of God. And I'm just saying that's fine. That's fine for a theist to do. But certainly it's never been demonstrated God did it. I agree. Because science can't do that. So it's a good point.
So I did find a quote from one of the papers. This was by Harvard where they tried to do the sun bounce. And it says, these citations demonstrate that the sun's plasma, both in atmosphere and solar wind, is highly absorbative, scattered, lacking stable reflective properties needed for practical radio wave reflection. Only under rare shock-induced events do any partial echoes occur, and these are not predictable or usable for routine communications or radar experiments.
Awesome. And how long did it take? About 1,000 seconds. So the sun's not local. That's all.
They were only getting very scattered, partial responses over long time periods. So it's a quote. The reflection of radio waves from the sun, if it occurs, is due to transient, exceptional plasma phenomenon, not steady conditions present in solar wind or regular solar atmosphere. if present. This was the title was Plasma Theory of Radio Echoes from the Sun and its Implications for the Problem of Solar Wind.
Yeah. But okay, so fine, you can't use it for that purpose. Not the point. The point is the sun can't be local. And so that doesn't contradict whether or not the sun can be local. Right? It doesn't affect it at all. So
there's an important change.
Right. The only way would be, maybe there was something that caught that signal and made it go really, really slow while en route somehow. Who knows? Magic? I'm not. Yeah.
Yeah, they said they needed better equipment at the El Campo radar unit. And it says needed for several reasons. Number one, the echoes are at times too weak to be detected. More details are needed in part of the echo spectra that are inherently weak, and noise bursts at times decrease detection sensitivity.
Okay, so sometimes they didn't get a signal back, but did they sometimes get a signal back? Yep. So the sun's far away. That's all.
But over like a wide range of time.
They never.
I can look up what was the earliest time signal they got back in the latest.
I don't know.
I remember. I thought
they
it was
never.
8 minutes.
They never got it back in the amount of time that it would require for flat Earth, though. That's for sure.
Well,
right?
We'd have to look at the filtered data of the total times that it was returned at.
All right, go do that. I know the answer. I know what you're going to find. Never will it show that it was only 10,000 miles away. That'll never happen.
I mean, I don't claim to have a distance to the sun, nor does it matter really, in my opinion.
It totally matters for flat Earth because flat Earth requires the sun to be local.
But I mean, I'm not trying to get biblical, but if God ordained day and night in Genesis, and places that would receive daylight and would not receive daylight, separated the light and the dark before even creating the heavenly lights, the sun, the moon, which happen to be the same size. But anyway, then it wouldn't matter because has ordained, day and night with the separation of the light from the dark over the face of the earth at the very beginning.
Okay, so if that's the case, then what's happened is God is deceiving us. If that's the case, because it looks like a globe, everything about it acts like a globe. Only 50% of the surface of the earth is illuminated at a time, and the pattern that is illuminated matches the globe. So if it's flat, then God is deceiving us. Is that what you're going to go for?
That's assuming we're not trusting his word,
I mean, if you are trusting in your particular interpretation of the Bible, then you are asserting that God is deceiving. That's what has to happen then.
Well, how would you just theoretically interpret he separated the light and the dark over the face of the earth before having the sun and moon rule over them?
As poetry.
How would you interpret?
As poetry.
Okay.
Just the same as in the Song of Solomon when it says she has the eyes of sparrows in her hair. Something like that.
What verse are you talking about?
It's in the Song of Solomon. Song of Solomon. That sounds pretty creepy. That's so she plucked the eyeballs out of a bird and stuck it into her. That's gross. No, that's poetry. It's not literal.
Let's pull up the verse. I mean,
I don't need to pull up the verse to identify that there are things that are poetic.
Yeah, there's metaphors.
Yeah, there you go.
Yeah, for sure.
So there you go. So you asked me how would I interpret it? I said poetry or metaphor. I'd say a metaphor. That's
God speaking versus Solomon. This is Solomon.
No, it wasn't. No, it wasn't. It was attributed to Moses writing it down, having been handed to him verbally over many centuries. That's how it was. It wasn't God speaking.
The wisdom of Solomon.
It was Genesis. Genesis was attributed to being written by Moses, which people are unsure of.
By who?
What do you mean by who?
Who attributed it to Moses? On the word?
That's generally the position of people that accept the Bible, is that Moses wrote Genesis. I mean,
okay.
You knew that, right?
Well, yeah, Song of Solomon's clearly, I mean, I'll just go off what the word says, you know what I mean? But if it says Moses wrote it, I don't think it says that. But
It
Song of
doesn't say
Solomon
that,
is
yeah.
definitely poetry.
Yeah.
Like the entire thing is poetry.
Yeah,
But God creating the earth is like, the word of the Lord.
I'd call it poetic, and that's an interpretation. So you're just taking a certain interpretation. I'm taking a certain interpretation. Which one's right? Both. Neither. Don't know.
It says the Bible is not up for private interpretation.
So then
it's in 2 Timothy.
So then there were eyeballs in Song of Solomon then, because that's not. I'm not going to interpret. You can't interpret poetry. Then you got to take it literally. And then also,
let's see
he sits above the circle of the earth and makes a tent for it, right? So now there's a tent above the earth, and a tent is what, 10, 15 feet high, and it's made of animal skins and sticks. I'm not interpreting it. I'm just taking what it says.
It doesn't say animal skins and sticks.
It says a tent. And what was the tent to the audience? Animal skins and sticks. Isaiah 40:22.
Okay, I'll look up that one. Did you have the verse for the previous one?
For what?
Isaiah. I'm sorry, the Song of Solomon. Did you have that verse?
No. I'm just saying, and you agreed, it's obviously poetry. So there it is. He stretches out the heavens like a canopy and spreads them out like a tent to live in. So if we're going to not interpret the Bible, we have to take it just straight as it is. Now, the heavens are the heavens are a tent. And a tent to the audience was very specific. It was not very tall, 10 feet tall, maybe 15. It was a big one. It was made often out of animal skins and sticks. Maybe it was some sort of a linen. So it could be linen or animal skins and sticks. That's now. We're not, you can't interpret it now. We got to take it literally, right?
Okay, so
that's what you told me to do.
Solomon, hold on, you keep interrupting me. Like, chill. The verse in Solomon was saying that the hair on someone's head was as black as a raven. Is that what you're talking about?
No.
As black as a raven?
Nope.
Okay, and Song of Solomon 5:11.
Her eyes.
Oh, I don't know if you're right about that. And it says her eyes are as the eyes of doves.
There you go.
But so that's not ravens, though.
I did say ravens.
By the rivers of water, washed with milk and fitly set. Yeah, like the whiteness of her eyes, and then the hair would be black as a raven. So
behold, thou art fair, my love. Behold, thou art fair. Thou hast dove's eyes. 115, Song of Solomon 115. Thou hast dove's eyes. Don't interpret it. What does that mean? No interpreting allowed.
You're like totally bulldozing right now. Listen, I'm trying to pull up the verse. You said Song of Solomon 115?
115.
I'm just curious. Okay, yeah, I'm like David and Psalms are quite like he says as this. There's black as this, white as this, whatever. Yeah, there's definitely those metaphors. I mean, the book is like 35,000 verses, over 100,000 words. You're gonna have,
but you said you have to take it literal.
Again.
Yeah.
Hold on. Chill.
Finish, June. That's fine. Go ahead, Taylor. Go ahead.
Okay, but like whenever it's saying like "Thus saith the Lord," like or "This is exactly what the Lord has done," that's not like poetic or metaphorical. Like that's, and we can see this with history, like the kings. If you've ever read the Old Testament, a lot of it's historical accounts of real events that happened that we've proven with archaeology. So these are definitely not written as metaphors, nor are they metaphors.
Well, yeah, history of the Bible, a lot of it is well established, right? But the stuff that's not history, like Genesis, it's not presented as, we can go and look at this and confirm this. It's not presented as history. It's to me, and I get to do this. It's metaphor. And to you, it's literal. Well, who's right? Well, it turns out I'm right because we can go examine what shape the earth is. It's not flat.
And the best way to do that?
There's many ways to do that. You could measure. I think I went over this before. You can measure triangles, very large triangles, and if the angles of them, of the inside angles, sum to more than 180 degrees, then you're on the surface of a concave object. And if they're all consistently the same overage, then that tells you the radius of that object.
Well, we even acknowledge whenever we go out to like do surveying, it's somewhere between flat and globe because they say it's refraction making it appear flatter.
The cool thing about horizontal angles is they're not affected by refraction. Isn't that awesome?
Horizontal angles.
Yeah, that's why I said triangles. Yeah, they're horizontal angles.
Okay, so yeah, you're looking at like the horizontal deviation in this case.
Nope, not a deviation. It's called spherical excess.
Okay.
Yes.
The spherical excess, the ones I've looked at, are definitely within standard deviation of, because it's so minute, the spherical excess that you can observe.
So
but if
minute,
you have some
huh?
data,
Absolutely.
I would like to see it.
MCToon.net/SE is where you want to go for that one. I put it in the chat there. And then you want to look at the transcontinental triangulation, the American arc of the parallel. Look at the triangles that were on the West Coast because they're significantly large, and they're way outside
which one? Okay, which one should I click on? Starting on page 42, 53, California, Washington arc. I'm sorry, you said the
transcontinental triangulation.
Okay. Do they have raw data? I'm just wondering.
Yeah, they have the data in there. So, and the really cool thing, and there's a spreadsheet on that page that you can link to, and all of the triangles have been input into this spreadsheet, so you can actually directly manipulate the data.
Mm-hmm. Okay, so have you are you familiar with any of these to know like any of the measurements off the top of your head, like how much spherical excess there was?
Yes. So you want to, like I said, you want to look at the ones on the east, or so the west side. And off the top of my head, I'm not going to be able to pull up one, but maybe I can. I think I have one in my.
Yeah, so I'm looking at this chart. It's page 63. Transcontinental data. Where should I be looking at here? I see observed angles, corrections.
You're not gonna digest this.
What is?
Hold on. You're not gonna digest this survey while we're talking right now. This is a serious study that you're gonna need to do to understand the topic. And like I said, you wanna start with, don't end with, start with the triangles on the West Coast, the ones over the Rocky Mountains.
Work together with the play of the sunlight.
Okay, because it seems like do you have any sort of charts with this data on it? Because I see observed angles, spherical excess, but that seems to deviate depending on, I guess, the observer. I'm not sure.
I don't know. What are you looking at?
Page 63, the one that you referenced.
Of the transcontinental triangulation?
Mm-hmm.
Okay,
do they have a standard deviation? Do you know if anybody got standard def for this?
Yes,
Just curious.
yes. Are you trying to digest the contents of this 1,000-page document on the fly?
No, but I do see the raw data, but you normally put it in charts to make it, well, if that wasn't their purpose, then they may not have. I'm wondering if anybody,
if what
has
wasn't
done
their
it.
purpose.
So it is digestible.
They do have the angles. They do have all of the angles of all the triangles in the networks.
Where do I find the standard deviation of these
on the
page
charts?
63?
On the charts. I don't know about page 63.
Log, distance. Yeah, observed angles, corrections, spherical excess, log, and then distance in meters. But I don't see where they did any standard deviation or p-value or anything.
Yeah. Take your time. Have a look at it. Work to understand it.
Is there a page number? My last question, is there a page number?
Yes, it's every chart that they have both vertical and horizontal angle measurements. And so each of them has charts, and they even specifically talk about the number of times that they did any particular measurement, because they occupied stations for multiple days and measured angles to other stations for multiple days. They talk about it at the time of day that they did it. They measured the barometric pressure at these different locations and the temperature when they did the measurements. They have all of their error analysis is detailed in there, and they even go over the math that they used in particular. Because at the time, this is in the late 1800s, when you have a network of triangles and you're working to solve a series of related equations, and you have 40, 50, 60 different related equations, solving that by hand, which is all that they had. Their computers were made of meat. The way to solve those parallel equations is super difficult and time consuming, and so they use different ways to do that. They talk about that. They specifically give a reference to how it's done using T.W. Wright's method and the book that he used where he published that method.
Yeah, so the spherical excess I'm seeing is like 0.13, etc. And then the error is, what, 0.33 meters, I think. Oh, plus or minus. Okay, yeah.
If it has the full quote symbol above it, then it's arc seconds.
Okay, so I wonder if they converted it to meters.
So you don't measure angles. You don't measure angles in meters.
Yeah, but they converted it to meters. Yeah, okay. I'm gonna definitely take a look at it. Jesse, are you pulled up with that page? Do you know what the distance in meters all the way to the right of the chart is referencing distance of what in meters?
Which page?
63, the one you referenced on the site.
PDF 63 or printed
For the
63?
transcontinental, yeah, printed 63. I think that's what he was referencing.
Oh, which one on his site?
The transcontinental triangulation. The United States.
Let's see here. Okay.
Yeah. And so, yeah, page 63 is where the spherical triangles begin.
Brain strikes, taking a trip down. Side effects like dizziness, only hog. Migraine again. Ubrelvy works different.
Okay, I think I got it up. It's 63 in the printed, and then it's 64 in the electronic PDF reader.
Sleep that lasts all day.
Yeah, so all the way to the right when it says distance in meters, what does that mean?
That would be the
distance between
point-to-point distance of the triangle sides.
Yeah, between stations.
Right.
Which takes after use.
Yeah, so to those who say you can't use theodolites at long distances, here's 18 kilometers, 26 kilometers, 10 kilometers, 25 kilometers.
What were the corrections for that were done right here on the second
aisle? So that's where I said where they're using the method by T.W. Wright. So when you measure angles, you have what they call residuals, and that is because all of your measurements are very slightly imprecise. And so when you put them together in a network, that's what you get in the end of the network of angles. There's slight discrepancies between them because of your normal errors in measurements. So to solve these residuals, you have a series of related equations. And so what you do is you rather than today we just do it in software because it's pretty quick. You use a method that T.W. Wright used. And it isolates the important ones, but what they do though is most of these are a zero sum game. So like, well, this particular angle was off by 1 arc second, and this other angle was off by 1 arc second. One was plus 1 arc second and one was negative 1 arc second. So what they do is they add 1 to one of the angles, they subtract 1 to one of the other angles, not varying the amount of degrees within the triangle, and they still get an overage.
The corrections seem much more than the spherical excess, though.
Yeah, like I said, what did I say where to start? What side of the survey? West Coast. So what you're looking at is the very first triangle that they surveyed. They're starting on 63. So now I don't know where you're saying, because I don't know if you quite have a grasp on the error that they're looking at there.
Look at my screen share.
The Viennese emperor moth blends in with the tree bark on the tree.
Cool. There you go. Yeah, so if you scroll up.
Okay, here. This is a better one. Could jump down to page 588, which is 616 of the PDF.
But I was just going to point out here the corrections being much larger.
Yeah,
like for example, 1.23
like
versus
you're not listening.
15 arc seconds.
You're not listening.
I'm
Start
just
on.
saying it's like 10 times bigger.
Start on the West Coast. So I got one here. I'll put it up here.
Okay, I'm on 616/588.
Yeah. So you look there. You got Mount Loma, Mount Diablo, Mount Helena.
Yeah, see in this case.
What page is it?
588.
616.
616 of the PDF.
616.
It's on my screen share too.
616.
Yeah, in the
clear
PDF.
for everyone on Jesse's. It's a little. Some of the digits are choppy.
Yeah, I'm gonna grab a better.
It's a little
one and
easier.
put
to
it
see
on
now,
my
Jesse.
screen. I'll drop a screenshot of it, but I just need to grab it quick. You need to get it to the right folder and copy it in to the correct folder.
Has a life of its own.
But yeah, because Jesse's is going to be a bit small to see. So
It appears
all right,
that a
all
water
right, there we're getting there, almost there. I'll drop it into Discord.
It's dangerous for the duckling to be
And
out
then
on its own.
pull it up on
Different element.
the YouTube here. Almost there. All right. So everybody on YouTube can see it. And and Jesse, you got it. And hopefully Taylor, you have it as well. So here we have Mount Lola, Mount Diablo, Mount Helena. And the observed angles, you got 28 degrees, 49 minutes, and 8.348 seconds. And so this is very precise. And the reason why they're able to be so precise is because they took so many measurements. Anyway, so that when they sum that up, they get 57 arc seconds over 180. That's what that 57 is down at the bottom there.
Genius of ducting camouflage is
So that there confirms that we're on the surface of a concave something.
thanks to their
Convex. Or
sorry, yeah, you're right, convex. And then we've got the columns that's corrections. And
My 616 does not match yours on your paper on your screen, Jesse.
It's 588 paper, 616 of the PDF. Though there are multiple PDF copies of the PDF, so it could be.
What page is it on the printed document?
588.
I tried to go. They told me to go 588.
Yep.
It's actually it's 616 in the
number?
actual document itself, but it's 588 for the printed copy. 588 will be printed at the top left corner.
Yeah, we're looking at something different.
I'm looking at Take a look at Jesse's live screen. You'll be able to see what I'm talking about. He's got 616 in the box, right? Is that 802 or 902 or something? But digitally,
yeah, 902.
Yeah, digitally it'll be 616 of 902, but it will
that's what I got.
correspond to a value of 588 on the paper.
I stepped my quality up too to the max.
Yeah, it looks much better now. Thank you, Jesse.
All right, do you see that yet, Taylor?
I'm just scrolling because we went down so much.
Great, and it works. This time, I won't
I trust that you're like in the actual paper scrolling, yeah?
Yeah.
Okay.
There's usually a way to jump to a page number by clicking in the little page number indicator and typing in a number.
in just one swipe.
Okay, I got it. You go ahead.
All right, she's with us.
Did you get you get to page 588 of the document, of the printed document?
Let's see. Yes, right here.
All right, so you see Mount Lola, Mount Diablo, Mount Helena.
Let's see. 588 tells me Utah, Nevada, California. Yes.
Yep.
See it.
You're there. Cool.
All right. So then we see these this triangle number 1, Mount Lola, Diablo, Helena, and then the angles, and then those angles sum up to 180 degrees plus that at the bottom there, 57.778. You see that? That's the that's the spherical excess of the raw measurement. Are you seeing that?
Yeah. Put your cursor on it, Jesse. There's so many numbers on the screen.
Okay, I have my mouse going around.
Okay. Yeah. See it.
Okay.
Yeah.
So that's the unadjusted angles, and now they're seeking more precision in what they're doing because they're trying to get the precise distances. So they do the corrections there. So those corrections you see are by solving that related series of equations, because they have a whole network. If you scroll up a couple pages, you see probably a diagram of the network of triangles that they're doing here. And that's what that corrections is. And then the spherical angles are adjustments that they make. That's after the adjustments. Right. So you can see they got the first one, Mount Lola. It's 28 degrees, 49 minutes, 8.348 seconds. And then they have the correction there. And then the new one, the corrected value in arc seconds is, instead of 8.348, it's now 7.900.
Okay.
Right. And then, so that's what this new column is, the spherical angles is. That's the adjusted value after they did some more precision. They're doing things to get more precision here. But the raw angles are still showing spherical excess. So true, false, is the Earth a globe? True. Spherical excess. What is the distance across the United States to precision in the centimeters range? Well, you need to get more accuracy.
Distance in meters right there is to the objects they're looking at.
That's between the stations. So they had a theodolite on Mount Lola, and then they had a heliotrope on Mount Diablo and Mount Helena, and they measured angles to them. A heliotrope.
What's a heliotrope?
A heliotrope is a instrument that's got a mirror on it that flashes it aims a reflection of the sun to the station that's measuring the angle to it, so they can get the position accurately, because they didn't have electricity on the top of these mountains, so they could have flashlights or at night, or they could have fires at night, but those are not super good. So the instrument they use is a heliotrope that reflects the sun. It's got a telescope on it, so they can aim at where they're going. So they'll find Mount, when you're sitting at Mount Diablo, you look over to Mount Lola and you say, well, at 10 o'clock in the morning today, we're going to start measuring. So the guy gets on the heliotrope and he looks down the telescope at Mount Lola and arranges so that it's going to be reflecting the sun to them. So then the distance in meters then is the distance between Mount Lola and Diablo is what that 107 is. So it's 107 kilometers. And then the distance from Diablo to Helena is 213 kilometers. And the distance from Helena to Lola back at the top is 218 kilometers. That's over on the right side there. And then
okay. And did they talk about their standard deviation below?
Yep, it's all detailed. It's all detailed in there.
Can you scroll down a little bit? Yeah, there should be some explanation.
It's on it. It's they have it on. Yeah, these are the tables of the measurements. You got to scroll up to actually get the where they're dealing with. Yeah, there you go. So this is the results that you're looking at. I don't have it on my screen here. Hold on. Let me pull it up.
What corresponds, if I may ask, to the specific measurement? If you're able to hone, I think you're watching Taylor. I think you're watching Jesse. If I'm guessing correctly, Toon, is there a possible way of you saying what corresponds to this number one Lola, Diablo, Helena standard deviation measurement, so that we can kind of like work from there and maybe kind of match it up so Taylor can understand?
So I think at the bottom of each of these groups, let me check here. There you go. Go down to page 592.
We're talking about 592 printed copy?
Printed 592, yeah.
Yeah, so that might be like try a 620,
620,
Jesse,
yep.
and then work from there. Yeah.
So here they're talking about the precision of all of these angles here, and that's what we're going to have in this this following part here. So, and they do get pretty detailed about how they do it. So the precision of the adjusted triangulation. But Taylor, I just want to say that the going after the precision isn't going to change anything, right? Because they measured a spherical excess of 57 arc seconds, and their precision is less than an arc second. So they're significantly above their precision there.
If I may steal, Taylor's position at this point in time, Taylor, and tell me if I'm wrong, it's something to the effect of, how do we know that the spherical excess can't be attributed to something like refraction, whether it's upward or downward refraction, or something else that might be interfering with our measurements? Maybe I'm right. Tell me if I'm right, Taylor.
Yeah, definitely I took into that. This is my first time seeing actual data for spherical excess. So thank you for bringing this forward, MCToon. I'm super pumped to look into it.
Yeah. Now you will hear potentially from other people that have not studied this in detail that will try to nitpick on these corrections here, that column that says corrections. But you'll notice that even if you take the corrections out, if you don't do the corrections, if you take the uncorrected values, you still get a significant spherical excess in these measurements. Now on the
this set of data,
on the East Coast, where the triangles are very, very small, and the spherical excess on these very small triangles is it's in the neighborhood of 1 or 2 arc seconds. It's not much, and so you can say, well, it's imprecise enough that we don't know. That's fine on those very small triangles on the east side, because they were, they started, right at the coast, and they're like just going across a bay, 3-4 kilometers across a bay. between stations. So it's not very much. But here they're going mountaintop to mountaintop, and they're doing 218 kilometers in a leg of these triangles. So these are fantastic large triangles, where the difference between the uncorrected and the corrected is 1/2 of an arc second. So
did they measure vertical angles too?
Yep, they also have vertical angles in here, but they're separate from the horizontal. And so there's a whole section in the if you look at on that page that I gave you, there's the spreadsheet. The spreadsheet pairs up reciprocal zenith angles all across the United States. There's a couple hundred reciprocal zenith angles across the United States. I don't think I have it on here. So if you go to Walter Bislin has a treatment of that where he looked at that data and he said, well, if the Earth were flat, what would the refraction have to be? And if the Earth were curved, what would the refraction have to be? And according to the temperature and pressure that they measured, what is the computation of the refraction that is expected from that? And it's very instructive. I'll just say that.
Yeah, overall temperature gradient is going to be pretty stable, but along the ground, that's when it gets to very steep gradients.
Yeah, and these out here on the other thing is very cool. A lot of these they're not going ground to ground. They built towers for many of these. So when they're going across the plains, across the United States, they weren't setting up a theodolite 5 feet above the ground. They were building towers 20, 30 feet high and putting the theodolite up on the top of that tower and measuring the angles from the top of that tower to another tower that had either the heliotrope on it or some other mechanism on it that you could see, so that you can get those non-skimming the surface measurements. And the book has some pictures. It's pretty cool.
Check my live stream. This is just a follow-up to the spherical excess. Somebody, and I'm not sure who, maybe Icy Spin, went through and put error bars and measurements to show how...
Wasn't me.
It wasn't you. Okay. I bumped into someone who said, that was his.
This was what inspired me to ask the community to put the data in, actually.
Okay, yeah. So you can see for the tiny triangles, the error bars do encompass the spherical excess, but once they get over a certain size of square area, then they don't overlap anymore.
So I'm showing on my live stream, not yours, Jesse, but the one from the document that I entered some of the data, and I asked for volunteers, and a whole bunch of people jumped in and just owned it. And so this spreadsheet is an absolute marvel of data entry, and found some typos in the original that were 120 some years old, that nobody maybe had identified these typos. So pretty cool stuff.
Did the spherical excess change through the daytime?
No. So what they did is that each of those, like I said, each of those angle measurements is the weighted average of all of the angle measurements they made at that location.
They don't have the raw measurements to see the variation?
No, surveyors don't do that. Surveyors give you their final numbers. They never do that.
Boo.
No, that's normal practice. Why would anybody want that? That's ridiculous.
I'll give my raw measurements.
Yeah, because nobody cares, right? Because surveyors already did what they needed to do to take that into account. And so when the surveyors in the field took and sent back their data to the East Coast where they're tabulating all this stuff, they didn't want all of this, you know, they didn't need all that. They're like, what was the angle that you got there? Give us, you know, the details and what you need, but we don't need to see the entire logbook. We don't need that. And if they did send it back, it wasn't preserved because that's not the important thing.
Right. It would have made their book, 100 times longer.
Yeah.
Because they took so many. But what they did do is they did have a defined, published procedure for taking their data in the field and calculating their standard deviation and their margin of uncertainty and everything. And so that's how they included that data in what they did record. So we do know what quality of data their raw measurements were.
Okay.
And
Thank you for that.
the thing about
I wish to
surveyors, this is super important about surveyors. If they do something wrong, they're on the hook for it. Right? If somebody's out in the field and they're like screwing around and doing the wrong thing and making blunders, that's their job. That they won't remain employed if they're not measuring good angles.
What I'd like to know though, Taylor, is the reason you asked your question about the raw data. What do you feel like, and that's tugging on you that it feels wrong about this? Like, get it out in the open. Tell us what the issue is with not having all of the raw parts of this published measurement. Like, what's tugging on you?
Well, normally when you get a publication, you have to like submit all your raw data, and so I was just wondering if that was on here. No big deal, I guess, but I was just curious to see it.
But are you thinking that though that these results, the way that they're publishing them, is honest and accurate, and that they're actually making measurements that can be quantified and that can be repeated?
I would assume. I would hope so.
Okay, thank you.
So, one thing that they do regularly is they in order to do surveying, you need to know the length of one side of a triangle to begin with. And they'll either use chains or they'll use rods, and they bump the rods end to end. It's a pretty painstaking process to measure the actual straight distance between 2 points. Can take weeks or months to do. And so like here I'm showing on my live stream the Salt Lake base net to YOLO base net. So YOLO's my favorite one because you only live once. But the Salt Lake one, you've got let's see, where is it? So the Salt Lake base net, they went from where is it? They got anyway, they measured the actual straight line distance between 2 points near Salt Lake. And those 2 points, are actually in marshes today, but they built towers that were 30 or 40 feet high. They document how high it was in there. And they measured that, and then they did this whole network across from the Salt Lake area. I don't know if this is quite the one on my screen. I don't know if it's quite right. But anyway, then over on the west side here is the YOLO. Is this YOLO or Mount Diablo? I'm not sure. I think there it is. The YOLO base net is over here on the left side. So when they measure it, I don't think it shows it on this particular diagram here that I'm looking at, but they compare then after they've gone across, hundreds or thousands of miles and computing the sides of triangles by measuring angles. And then they compared the computed side length to the physically tediously measured length of the triangle, and they're off like 2 or 3 centimeters. The precision is amazing. And so if they weren't doing a good job, if they didn't know what the hell they were doing, these measurements would not match the computation. None of it would match up. It would be a disaster. and they need both the vertical and horizontal angles to get it right, because when you're doing this kind of surveying, you need to know the elevation of things. So when they're sitting here at the top of what is this, the summit station at Ucamfagre Peak in Colorado, which is an altitude of 4,355 meters, they need to know that elevation in order to do all of their computations correctly for measuring distances. And so if their reciprocal zenith angles, their vertical angles that they measured to get that weren't correct, then that would be off, and all of their other distances would be off. You've got an amazing series of measurements that all have to be correct in order for any of these things to work out.
Get help right away for allergic reactions like throat breathing.
So when people are like, oh, they baked in the radius of the Earth into these. Well, if that was the case, then none of these things would be right, and it would show in the results. So, all right, sorry, go ahead.
I was just reading about this like binaural horizontal refraction. I'm gonna read some more on it. It's a thing.
Yeah, it does, but in order for it to happen, you need to have a horizontal temperature or index of refraction gradient, which is pretty rare. And like if you're going near if you're going in a valley or a chasm and you're going near the rock wall of some thing, then you could have some horizontal refraction. Yeah. But when you're out in the open, just one more thing. When you're out in the open and you're doing it, multiple times a day over multiple days, they will average out. So, okay, what, Jesse?
There are two new people with their hands up. One's called And the George Said, and the other's called Sky Hunter. And then Tom Zig also has his hand up again. Just wanted to let you know in case you want to.
Well, all right.
I'd like, yeah.
Go
Can
ahead,
I get a conclusion? Yeah, thank you. So Toon, like reading over this document, this is let's be fair here, okay? Taylor's seeing this for the first time. She's got to go back and look at it, and she's done a lot of studies on refraction, and I truly appreciate that she's looked into this way more than anybody else, like that I know of, Taylor. I truly do commend you for that. With that being said, Toon, what the conclusion of what you're looking at this document, right, with all of the measurement, to present to Taylor in a way that she can digest and think about when she's looking this over and corroborating it with some of the things she's done. Can you give me like an elevator pitch about, hey, these measurements do this and do that? Let's consolidate it into an overall conclusion. And I know the answer is going to be, it can't be flat or whatever, but like, hey, when we're looking at spherical excess, maybe come at it from that sort of angle to where she can kind of have an eye on that when she's looking over the evidence. Do you mind doing that for us, Toon?
Yeah. It's a big document, and it's a monumental survey, and there's more details published in this survey than many other surveys. When you look at the survey across India, nowhere near the detail. Same thing for across Europe or England. So that's what's really nice about it. So yeah, do we want to have the books and books and books of raw data that they tallied up to? Yeah, that'd be great. But in the end, the testament is to how correct it was. So if they did not have accurate measurements, then they would not have accuracy when they got from the East Coast all the way to the West Coast, and they measured that YOLO baseline physically, and they measured the YOLO baseline by the angle measurements. To be in agreement, it wouldn't work if they didn't have all of the other stuff prior together working. So certainly look at that if you want to look individually at individual triangles. The ones on the West Coast are really cool because they're so big. The ones on the East Coast, the first couple of them in there, yeah, the margin of error is wider than the spherical excess. You're correct.
So I think what we're looking at is the overall conclusion, and I'll let you go in a second, Taylor. But the overall conclusion is that when we add up all of the triangles and we see what the error margin should be and what the spherical excess should be, there's a discrepancy that says, not so sure that this lays out to be some sort of flat horizontal plane that some might purport. Is that fair?
Me or Taylor?
Sure. I mean, yeah. I mean, I thought the same thing.
One sec. Just for Chin, is that fair? That's kind of the overall, like, that spherical excess is in much greater discrepancy than what the error margin says.
Yeah.
Okay, and then Taylor, go ahead and respond. Thank you.
Yeah, I mean, I have to I look over everything, you know what I mean, before I make any conclusions. I have to go read about it. I have to go read about other variables to take into account if there are any. So, you know, before like going read a few papers on it, I don't want to draw a conclusion because I'm not sure of all the variables. I've studied a lot of vertical refraction. I know that there is some papers on horizontal refraction and how, golly, I'd have to pull them up. This was a while back. And how they did see like a horizontal refractive like deviation that was happening consistently. But this was so long ago, so many papers ago that I cannot quote it.
There is,
but I would be
there is
interested to see it.
something,
And like the margin of error in the actual equipment and at these distances, like, you know, making out how far away were they for the from the observation point again?
some of them are over 200 kilometers.
How many miles?
I think what he stated is
120.
Well, you'd have to do the conversion. Yeah.
Oh wow! See, that's the like to even make something out of 120 miles is like crazy, but yeah.
You're going to see it being a lot more.
It'll be hard to make out.
Well,
yeah,
that's why they use the heliotrope.
Right. They use the center, basically.
Oh man, 120 miles. That's further than some of Jesse's measurements that he's ever done. Oh man, and so how many arc seconds is that again that they were measuring in that last chart? Let's see.
57 arc seconds of spherical excess.
Oof. Yeah, man. After looking through a theodolite, making out 57 arc seconds over 120 miles is crazy. But yeah, I guess they might have like some impeccable conditions where I don't even know how it wouldn't be waving and moving at that distance.
No,
like,
they were the one benefit they had is they were at high elevation. So
yeah,
it's less air. They're not sitting in, you know, above water and things like that. And the theodolites, they had 18-inch telescopes on them on that part of the survey.
It doesn't matter how nice they are, the theodolites. It matters about the atmosphere between you and 120 miles.
Yep.
So that's a rough, but it's okay. I'm still gonna look into it a little bit more. And the dineural movements of horizontal refraction. I remember being shocked, and other people were shocked that there were changes like that. But you just have to go read into the literature a little bit more.
So
because sometimes they say, "Oh, there is nothing there that could cause this," and then.
So this is the important thing about horizontal refraction. When they're measuring these, they're measuring not just the angles between two. They're doing the full circuit. So they're going typically, they'll start with one and they'll measure to position A, and they measure the angle to position A, and then they turn it to position B and they measure that angle and write it down. And they turn it to C and they write it down, and then D and then they write it down. And so they're not measuring just the angles between any two things. They're measuring the angles, basically the percentage of the circle that they're measuring. So if there's horizontal refraction, it affects all of them, and you still only get 360 degrees in that circle. So what it would do is it if there was a consistent horizontal refraction for some reason, it would make that particular angle of that triangle either bigger or smaller consistently, right? If it was a fluctuating thing, then over time it would average out with, your Gaussian distribution. But if it was consistently, then that would set off that entire triangle for that whole time, and you would know because that would affect your precision.
Yeah, imagine a grid that's been built over the top of the United States, and they're just connecting lines of triangles, sort of like Shoebell posted at 1:46 a.m. my time, so 46 after the hour. You see how all of those interconnected lines, imagine that being stretched all across the United States, and one thing leads to another, right? What can we surmise by the West Coast being significantly different than the East Coast? Is that those measurements in and of themselves, sure, there might be a little bit of a fudge factor here and there, but they're going to come out in the wash, right? So that's why it's important to look at the data on the whole and try to understand, hey, over I don't know, over Death Valley, sure, there might have been, the temperatures might be normally higher than normal, and they may have been at a lower elevation, right? You can kind of piece those things together in your mind about why one measurement might have been different. And Toon's showing it on screen, the Salt Lake base net to YOLO base net, something like that. The way that they kind of grid and map together, we're looking at like a start and a finish, and we're trying to kind of piece together what the entire puzzle is telling us, and not just any one measurement, much less one triangular sort of I guess assessment of what we're looking at this particular junction along the route is all I wanted to say.
Yeah. Bobby Shafto. Dude, you got to come up in here. All right, Taylor, anything else?
No, if I send you these, I'm reading one of the papers on horizontal refraction done early. If I send you this paper, will you check it out?
Yeah, I've read 2 or 3. It might be one I've already seen, but yeah.
Okay, yeah, definitely.
Hey Taylor, thanks for coming up. I really appreciate it. I'm glad that you and I have talked a little bit about this, so I appreciate it.
Definitely.
I just sent
send you back down, okay?
I sent an invite to Bobby Shafto to come up. Oh, he turned it down. I love Bobby Shafto. If I'm a fanboy of anybody, I'm Bobby Shafto fanboy. That's who I am. Seriously, back in 2018 on the Flat Earth Society TFES.org servers, he was up in there. Man, he is good.
So Anna Jord was, I know that Jesse gave you the State of the Union a second ago. She was here earlier. Guy Hunter came in after her, so, and I sent her a message in the side chat. I haven't heard from her.
So yeah,
but I'd love to hear if she has anything for us.
Yeah, Jord is a not a flatty. He's a good guy. Who was the other one?
Okay. Sky Hunter. Anna Jord came in. So
yeah, I don't remember. I think I recall Sky Hunter.
Okay.
Oh, Bobby's multitasking. All right.
What's up, guys? Hey, Toon, I just wanted to stop in. I need a little advice if you can help me out real quick.
Yeah, put the lotion on twice a day, not once a day.
I hired this handyman, right? And I left a huge list of stuff for him to do. There were like 10 items on it. And you only did item 1, 3, 5, 7, and 9. I guess he only does odd jobs.
Yep. He only does odd jobs.
Do you have any advice? Should I just fire him?
Well, I would write the second item on the even numbered items on the list to be things like eat all of your popsicles from the freezer. Yeah. Knit the dryer lint into a sweater. That stuff like that.
You prove the flatter, you know.
All right, Sky Hunter, I'm going to let you up. Let's see what you got for us.
is Sky Hunter hunting the sky.
What you got for us, Sky Hunter? Welcome. You there?
You might be trying to get the audio working.
Yeah. Got any supers pending?
I do. Let's see, Earthy Skeptic says, looks like Flurf likes elevation angle foreplay. Yeah, he didn't want to talk about it. He didn't want to go to the conclusion there, I guess. Tim Davidson says, and if the Southern Cross is 18 degrees above horizontal, where does that put you? Puts you in the Southern Hemisphere? No, it doesn't. Depends. There's a few stars in the Southern Cross, isn't there? And I don't remember I don't remember offhand the declination. Hackroman says intelligence is thick with this one. Yeah, that was Tom Zig, right? Rough. Tim Davidson says, how do you make int and cha dump stats? Int and CHA dump stats. I don't know. I don't know what that means. Earthly Skeptic says 90 minus 18 equals 72, so Earth flat. So yeah, he didn't know where he was going. He was going down a path, and there was no intention of going anywhere. Hackroman says, here's the one licking the window on the special bus. He's the one licking the window on the special bus. Yep. Gonna need a shorter bus. Rossi says, ask him what he proves with vertical displacement. And that was the mystery, wasn't it? What was he going to actually solve? Nothing was going to be solved with it, because it still doesn't actually provide the geometry that matches flat Earth. We still have that little bitty problem of Polaris having an actual physical location above the flat Earth that's different for every observer at different latitudes. And then, but they're going to go for magic reasons. They don't match. It doesn't matter. But okay, so you can or can't use the elevation angles of stars to measure, to figure out where you are. Slithery says, how did you titillate an ocelot? You oscillate its tits a lot. Oh my God. Is Sky Hunter still working?
How you doing there, Sky Hunter? Got anything? Maybe we should send the authorities on the next go around.
It says Leslie Rohrer. I don't. Why? You don't think? Oh, that is Leslie Rohrer. Oh my goodness. Yeah, I forgot. On Discord, Leslie is Sky Hunter. Rick to Bits says this is painful.
Andrew's got his hand up. He's a flat earther.
Is he?
No, I sent him a request. I sent him a request.
Good. Okay.
Andrew, if you want to come up, man, I know that him and I have spoken a few times.
He's gonna have the geometry.
He's bounced in some of the he's bounced in some of the labs here and there.
Oh, this is my favorite.
It could be interesting.
This is my favorite here. Picture that Shoebill just posted. This tower, they're way above the trees, and the theodolite is in the middle. And YouTube is a little mangled. I'm sorry, but the middle of the tower is independent of the outside of the tower. The theodolite's on the middle of the tower, and the people are on the outside of the tower, so that as they climb around on it, it doesn't cause the theodolite to move around. That's how precise they're trying to be. Really cool. We got Brocal says, whenever I think Flurfkin can't get any dumber, then Tom Ziggs shows up. Evil Producer 1 says, if I'm on the Mayflower on top of Mount Everest, but Polaris is below the angle of viewing of the Titanic, then welcome to Flat Earth, you artard. That's about it. That was it. Let's talk about a whole bunch of geometry that doesn't link to anything and then say, welcome to Flat Earth. That's not how it works. 78 Mitsu says he must have the new Flirty soundboard. All the new Flurf sound effects board with 40 Flurf statements of fact with retorts, you moron. Oh, yeah. Itoria says, I also use molasses in sex tense. Yeah, I don't think that. I don't believe you. I don't believe you.
Taylor might have another thing or two to mention. She put her hand up recently.
All right.
So go ahead and I'll invite her up after.
All right. Wildly Coyote says they ask a question they won't let you answer. Yep. That's how you know you won. When they ask and just don't even stop.
Oh, Andrew's up. Okay, cool. Taylor, I'll have you up after. I think Andrew's gonna chat with Toon for a minute. Go ahead. How you doing, Andrew?
Your audio is pretty low. I can hear.
Can you hear me a little bit?
Pretty well.
Better.
I can hear you well enough, but I just got.
Alrighty.
Okay. So I was.
Good to see you.
I wasn't trying to join in, but someone was asking me to join in, I guess.
Oh.
Yeah. So I mean, Andrew, you and I we've chatted a little bit here and there about some of the topics that you've brought up. I know in particular you brought up your diagram of the moon and about satellites circling. We've had a little bit of a conversation about that. I think some of the other things have just sort of been, I kind of dropped in the middle of the conversation, so I can't really expand on that. But I know that you've got a problem with certain things. I thought maybe it would be a good opportunity for you to present them. And maybe Toon can give you his perspective, and it might be productive for both parties.
Are you talking about me, Andrew?
Yeah, you, Andrew.
Okay. Yeah. I have a lot of problems with it, with globe Earth and flat Earth. But the main thing that I will actually bring up with evidence as to why I believe that the Earth is different than what we're told is that was the. Pardon me. I just worked a 14-hour shift. I'm a little tired, and I already had a couple beers, so bear with me. Is that it was the moon landings and the space missions and things like that. So I would be welcome, because I've already had several people challenge me on this, and I have some, in my opinion, dead-proof evidence that the moon landings were completely hoaxal. A fraud.
No, yeah, that's fine. Toon. So Andrew, just to set the record for the moment, the topic that we're debating is flat Earth evidence, so on and so forth. Toon, I don't know if you, I don't know if this is something that aligns with something you want to address, Toon, or if maybe you want to steer it a different direction. How do you feel about it, Toon?
Well, I've been going for quite a while, and I think introducing a new topic now might be a little bit much.
I agree, and I don't know how long the stream's actually been going for, and I'm going to be setting up my new computer, changing it from the one I'm currently on, which is kind of failing over the last 10 years. But anyways, when it comes to flat Earth, globe Earth, well, a lot of people got into flat Earth because they figured out that the moon landings were a bunch of hoax. And after that, I started looking into other things. So I'd be happy to have a conversation with you or Jesse. Jesse's already agreed to me about electrical engineering and electronics and different theoretical physics types of things to discuss.
Are you an EE?
Almost. Well, I'm not a certified.
So did you got the bachelor's degree in EE, and you just need to take the standardized testing?
Yeah.
So you have a bachelor's in EE?
No, electronics engineering.
Oh.
I never went and took the actual certified test on it, and that was a long time ago.
What was your schooling?
It was electronics.
Okay, so you have a bachelor's degree in electronics engineering?
Yes.
Okay. All right, that's all. I was just for clarification.
That's fine. Not a getcha or anything.
Yeah.
He's just wondering how he needs.
Yeah, I've taken math courses and all that kind of stuff as well. But that's not even here nor there when it comes to the point I'm going to bring up in regards to the moon landing. I'm sorry, alleged moon landings. I have points I'll bring up that are not necessarily heard of before.
Maybe what you can do, Andrew, is kind of wrap that into a flat Earth, because I know that you're a flat earther, and I'm not saying this in a derogatory sense, but I know that you have problems with the globe when it comes to sort of how it relates to that. If you can kind of wrap a bow on that, like, does that make sense?
It does.
Okay, thank you.
So I keep getting these notices. I don't know. I blocked some people on Discord and then I unblocked them, but Discord is still giving me a notice saying that I'm still blocking them. I don't know why that's happening. Discord is messing up. All right.
So all day it has been.
Say what? Jesse, what?
Yeah, all day Discord has been messing up.
No, this has been going on for months.
Oh, okay. Sorry.
But yeah, when it comes to, I wasn't planning on speaking at all, but then I got a notice from someone saying I was being invited.
Yeah, it was me.
That's the only reason I'm speaking right now. And I am very hungry. I'm making some food, listening in the background. But in the meantime,
what if we set it for a different day?
Yeah, I'll have to prepare it. I mean, I work full time. Actually, I work more than full time. So I will have to put.
I work full time too. The NASA Shield paychecks still haven't come in, so I've still got to work.
Well, maybe you should audit NASA then and find out how that's going to work out.
Yeah, Toon, you have availability like Thursday or next Tuesday, or I know his schedule's been pretty consistent.
Yes and
maybe,
yes.
Maybe you can find a date. Okay, Andrew, how does your Thursday or following Tuesday work?
I work. Okay. It's 12 hours a day or more.
Yeah.
Monday through Thursday. And then Friday is usually the time I just take off and don't really get online much. And it's like kind of where I just spend time with my girlfriend. And then from there, Saturday and Sunday, I'm usually doing side jobs, electrical work. So yeah, my schedule is a little more cramped than
if I may propose something, Andrew and Toon, maybe I can kind of help. We can bridge the gap and we can find a time that works. Like over the next week or two, we'll sort something out and we'll make it work. Is that okay, Andrew?
That's fine with me. Yeah, but I would have to prep it because I don't want to just start talking and then not have anything to back it up with, because that's super annoying to me when people do that.
Cool. Sound good to you, Toon?
Yeah.
Yeah, I'm happy to facilitate that. I'll be in touch with both of you and we'll figure out something that works. Thanks for popping up, Andrew. I know that you're on short notice. You just accepted what I sent, but yeah, enjoy your food. I think Toon's probably getting ready to wrap up anyway, so
yeah,
I'm gonna go ahead and boot you down to the audience. If that's
sounds good
with you.
Yep.
All right, man. Appreciate you.
So a couple days ago, Ashton Richards asked if I would say that he changed his name to Cola Guts. I'm like, yep, I can say that. And here's his picture. There's Cola Guts. Let me drop it in Discord too. So there you go, everybody. And please note the Mexican wrestler with the dog is Cola Guts. And I'm like, yeah, I can tell people, but remind me. So he just sent me a message reminding me. All right. Well, tell you what, I have a few more super chats to read, but I'll just wrap it up here and then head just on my channel to wrap them up. I just want to say, Riggs, this has been great. Thank you so much for opening this up. I appreciate all everybody that came. Taylor, Tom Zig, D-Mock, Andrew, and the good help we got from IC Spin and Jesse and Buck Sidebuster and
Arnold,
Swingfish, Arnold. Yeah. Sky Hunter hasn't said a word yet. My guess is he's server muted.
I'm not
It
seeing it
could
on
be.
my end. Looks like you could.
And
one.
and
I'll
of course,
server mute him and unmute him. Sometimes that's what it takes.
Oh, all right. And then of course, I'm a fanboy, Bobby Shafto.
Oh, so I can't make a comment, says Taylor. If it's quick, yeah. I mean, I can pull you up. I saw your hand was raised. I sent you a private message, but yeah, pop on up. You have something to say, and then I think Toon's going to wrap it up.
Yeah, and then it's going to be
Go
Dearth
ahead
or
and accept
Potato
that.
in the end. We're going to wrap the whole thing with Dearth or Potato.
Yeah, super quick. So one thing about mountains, whenever they do horizontal refraction, is that if it's near a slope, you're gonna have like the mountain breezes and valley breezes and the higher gradients near the mountain, where you have like, higher temperature and pressure and possibly humidity, depending on the type of environment that there is. If there's a lot of greenery, maybe more humidity than others. But they have larger horizontal pressure and temperature gradients. So this would cause like the higher diurnal variations, which would basically do the same thing as like vertical refraction, but like whenever you have it along the ground, if you have a slope surface, if you have those higher gradients near the edge of the mountain, that's going to cause a sloped horizontal plane. And, they have like, you can look at the way air currents move up and down mountains. And basically you're going to have that more horizontal gradient that's present. That's just one thing to mention. And then there's also like diurnal variations as well. But this will be especially predominant near mountains. But I can send you a couple of these papers that were done on like level surfaces and like in high altitudes.
Yeah.
Does that make sense?
It does, but also remember, because of how they did these particular horizontal measurements, it's a zero-sum gain. So if one measurement was consistently 2 arc seconds to one direction, that would cause the other triangle that's next to it to be consistently 2 arc seconds opposite. So it would modify that particular measurement, but the entire network wouldn't get a total of 362 degrees in that circle. You still get only exactly 360 degrees in that circle. So it's not going to have a difference like a reciprocal zenith or a vertical angle would, because the vertical angles you're only measuring that up and down, just the one. Where when you're measuring horizontal, you're measuring all the way around.
Mm-hmm. And so the 3 observation points were all on like, I thought one of them was on like a level ground and 2 others maybe on mountain peaks. I don't know. I'd have to look at the materials and methods, which are extremely clear for each.
They're all at, if they're on mountains, they tend to be on peaks, and if they're not on mountains, they would tend to build a tower or be on top of a building. There's one of them is on top of an insane asylum. That's my favorite. That's the name of the station, Insane Asylum.
How do you know? How do you know where the insane asylums are?
The building is still there.
It's part of what they purported where the measurement points was.
Yeah. They went on top of it.
Though, like I think this could be a productive conversation at some point. Like if you want to do it like a Tuesday or Thursday, Taylor, you can message me anytime on Discord. Toon's got a lot on his plate, but I'd be happy to try and coordinate it. And
Definitely. Yeah, definitely. So yeah, there's just something there to look into there. I just wanted to give like an example and an explanation as to how, because a lot of people discount horizontal refraction, but maybe if you understand like why some of these concerns are brought up, you'll have a better understanding. It'll be more, understandable, logical, to conclude.
Okay.
Sorry, I'm trying to wrap it up as quick as possible.
No, you got it.
I love how she's going to teach me.
I know you came up here with a thought on the top of your head, and I think you articulated it well.
Yeah. Thank you.
Yeah, absolutely. I think Toon's wrapping it up, but thank you.
Yeah, he did a great job. Thank you for coming,
being
MCToon.
a part of it.
Yep.
Yeah, cool.
Glad to be here.
Thanks.
All right, I'm gonna pop out now, and everybody, we'll see you next time. Bye.
All right.
right. Well, I think it was adorable that she thought she was going to teach me. But, I got more to learn. Always got more to learn. But I think, yeah. At least she wasn't condescending about it. Other flat earthers that don't understand even the basics of geometry are like, oh, I'm gonna teach you about. No, you're not. No, you're not, buddy. Anyway, I was not kidding. I really do have a ton of respect for Bobby Shafto. If you haven't seen, he does have a YouTube channel. He doesn't. It's all different. It's not like I do. It's not like FTFE does. It's just basically video of his observations, and it's really good stuff. So anyway, Itoria says, everyone thinks AI is some all-knowing sci-fi super brain. The real world AI we have is just a high school freshman that's learning how to plagiarize essays and how to talk fancy in front of the pretty girls. That is 100%. 100%. Itoria also says, it's the same as Flurfs. It just spouts out information it's seen posted online, whether it's correct or not. Yeah. I've been impressed with some of the things that it can do. Some of the things that it could do, like putting things together from different sources, like synthesizing information, and it sounds pretty good. But yeah, if it hasn't seen in some way, if it has no background, it's gonna struggle to put it together. Wild Lee Coyote says, finally a flat earther that is wanting to learn and is not yelling and cursing and constantly interrupting. This kind of discussion I want to see. Yeah, that was good. Dan DeMann says, Dick Wayne, you are the dumbest person on the globe. That tomorrow is the day to start nominating a Dick Wayne. You might get a nomination. The problem is that, it's always best if you're on screen. That makes it tough if you're not. But Alyssum says, I thought you were asking Flurfs to provide measurements of flat Earth. Are there any geodetic surveys that can provide showing a flat Earth? Of course not. And that's the thing about these claimed debates. Like, no flat earther ever has evidence for anything. It's just a game. We just toy with them like a cat playing with a mouse that's almost dead, right? That's it. They paint themselves in a corner. They describe a triangle that results in this particular elevation of a star. They actually say the words. You got an angle, you got a side, you got another angle. You go through that, and you're like, we have a triangle. Now we know the elevation of that star above the surface of the Earth. That's the whole point of what they're talking about. Like, oh no, but for some reason, that doesn't matter. Celestial objects get special treatment. Why? Begging the question is why. So, anyway, you put some heat on their feet, you let them go. You let them run off onto some other topic. They're like, oh yay, I'm gonna go it right, and then they get, you put some heat on again when they paint themselves into the next corner, and then they take a victory lap afterwards. They're like, did you hear that? I totally smacked him down. He didn't know what a Mercury table was. Like, I know what Mercury table is. It's so funny. Tori Hanzo says, still no flat earth proof. Am I shocked? You should not be shocked. I think I got everything. Let me double check. Double checking. It's been a marathon. It has been a marathon. All right. It will be Dearth or Potato. Because who said it? Who's my top left? My top left will be tomorrow. I'll announce my top left. So tomorrow, 6 p.m. Central Time, we're going to start in Craig. Then go for an hour. Then come to my channel for an hour. And then go to the Crunk Debunk for an hour. And we'll just have them linked together so you won't have to do anything. And you'll show up at the next one. It'll be amazing. All right. I'm looking just a second. Almost to Dearth or Potato. There it is. All right, people. Thank you so much for joining. I will see you all tomorrow. Actually, I won't see any of you tomorrow. You'll see me. And then, never mind. We'll see you.
Pick it up, pick it up. Is it dirt? Is it potato? Watch the screen and wait for the show. What's revealed, we're dying to know. Is it dirt or a potato? Check it out. Dirt or potato? Yes, I'm right, let's go. Dirt or potato? It's the game that steals the show. Look at the picture, don't make a mistake. Is it a spud or is it a face? Out of the ground or from his own behind? Dirt or potato, what will you find? Right on! Yo, can you tell what's underneath? A derpy mugshot or a root beneath? With every guess, we laugh and cheer. Is it dirt for a potato? Let's make it clear. Hang it up, give it a show. Dirt for potato, let's go. Skank it up, skank it up. Is it from the dirt or a funny disguise? Could it be a tater or a pair of eyes? What's in the ground or lurking around? Dirt or potato, where will it be found? Could it be smooth or full of lumps? Maybe it's grown on someone's big rump. Get your guess in, let's see what's true. Dirt or potato, it's all up to you. 1, 2, 1, 2, 3, 4. Look at the picture, don't make a mistake. Is it a spud or is it a face? Out of the ground or from his own behind? Dirt or potato, what will you find? A pile of soil or a starchy friend? Guess it right and you'll ascend. Look real close, don't let it slide. Is it dirt or a potato waiting inside? Let's go, rude boys. A garden patch or a silly trick? Will you pick the right one or end up quick? Whether it's dirt or a golden spud, dirt or potato, here comes the flood. A mystery unfolds, what will it be? A lovely spot or dirt, can't you see? With every reveal, we're in for a laugh. Dirt or potato, it's the ultimate craft. Dirt or potato, guess it right, let's go. Dirt or potato, it's the game that steals the show. Beneath the earth or just pretend, a lump of soil or some dumb trend. Pick your choice, don't hesitate. Dirt or potato, now seal your fate. What's in the box, what will appear? A mash of dirt or something unclear? Make your move, we're almost through. Dirt or potato, it's all on you. Will it be fries or a dirty pile? Guess it wrong and we'll laugh for a while. Test your luck, it's time to go. Dirt or potato, let the guessing flow.